And you can also go through and utilize Claude if you choose to do so. So the repository has all three of those options for you. If you want to use Claude to help walk you through it, that would probably be the easiest when you first do it. So it will go through, ask you a bunch of questions about your setup based off what it determines from your server. Make sure that if you want any adjustments on RAM or CPU, etc., it'll prompt you for all that. And then you can tell it to go, and it will start firing off all these virtual machines by first building out the templates, as you can see down here in the 9000s. And then once it has those templates, it can start cloning them off to actual virtual machines. And you'll see these various tags that go across there. This is for various learners that it's testing. And it's just a good way of isolating. That way you can use a tag view if you wanted to up here, and you could filter out based on what those individual tags are. So pretty handy. And Proxmox, they have a couple different ways of looking at it, but it's great for troubleshooting and kind of testing things out. So we'll come back to that here after we get through a little bit of the content here today. The plan is to still get this full working setup that she had diagrammed out. And then from there, we're going to be sprinkling in some AI things that we're going to talk about during the class today. Those are also being built out as templates through here. So you'll see this NLP01. That'll be one of the AI systems that are in there that you'll use for log analysis and a couple other things that we tried to get in there. So should give you a full-blown SOC with AI and part of it, and a couple different ways of using that AI, not just to build it out, but to also perform the jobs of a SOC analyst. So day 4 should be released out here on the website. If you have it cached, you should be able to just do a flush and refresh. And that should get us some information here. I'm going to talk about a couple of topics here and then jump into the slides themselves. Anybody have any questions or thoughts about today? Or did they come up with anything overnight they would really like to have got out of the workshop or the content here today? Okay. Well, much like yesterday, we're going to go through some content, and we'll just continue to build out that SOC environment. Those recordings will be there. Yesterday's recording is still being uploaded out there. So if you come out here and look at the YouTube playlist, you should have day 1 and day 2, and day 3 is on its way coming up there trying to process through the YouTube stuff. So the main focus of today is going to be the AI assisted security. This is about 24% of that SEC AI certification exam. And so a couple of objectives that we're going to try to cover is really learning how to implement an MCP server for doing the log triage and CVE summarization using any kind of MCP SDK. So we're going to build out an MCP. I know I've talked about those several times this week. And the idea behind that is you can use RAG, right? So we already know that the main ways to process logs. We can just upload the log, which then transforms that into tokens and then dumps that into the context window. And then we can do really quick lookups of everything that's in the context window. The problem is we could potentially leak things immediately in that context window, and other questions put inside of there could reveal information we didn't necessarily want. So we then learned to use RAG, which was a better method, and that would allow us to pull in multiple documents, and it would do a lookup on that without having to fill the context window. So it would just retrieve the information you need and pull that back into the context window, as opposed to having the entire document loaded up in the context window. And now the third way that we're going to do that is with an MCP server. So that MCP, instead of having to put that into RAG, we would use it as a method of looking up against a log server, for example, Waza or Logstash or anything like that. If we pointed out an MCP server there, it would do the request from that individual log server, figure out exactly what we want to ship back to the actual model, in this case, the inference model. And then from there, it would come in and put it into the context to display you. So Same concept. It's just instead of having a separate RAG style database, we'll use existing Logstash servers or Suricata in this form, or any of these other systems that we're building out for a stock. The next objective is to look a little bit at what an AI coding agent looks like. So from the ability to generate, see what's statically validated, and then any kind of repair loop. And we're going to do that to produce any kind of Sigma or Suricata detection rules. This will be a good start for those of you that haven't really played with the likes of something like Claude Code, where you've dealt with Claude, you've dealt with ChatGPT, but you haven't really dealt with a straight AI coding agent. Then we'll take a little bit more at evaluating generated rules against actual static validators. So those static validators are kind of preset rules, so to speak. So whether that comes from the Sigma SLI or CLI or the Suricata T, self-test, that kind of thing, without any kind of live packet capture. And then we'll conduct an AI-assisted vulnerability triage on a bundled CVE set with no real live data. That avoids any kind of hallucinated CVSS. And at the end there, we'll identify and escalate local models to a hosted API based on a task completion and the hardware constraints. So this is going to be a little tough. As we start to implement some of these, it does require some bigger hardware. We will be able to still do that in the classroom, or at least demo the purposes of that. If you were to do a bunch of the heavy lifting in here, then you would tend to want to have at least some kind of GPU available on a system so that you could make that more accessible and more reasonably usable in the classroom environment. So the first 3 days were all about how to secure the AI systems. Day 4 kind of flips that to, we want to use the AI to do the security work faster. So we build a real MCP server. We're going to drive it with some local tool calling model, which we demoed those a little bit yesterday, where they go a step beyond just generating text or maybe be able to have a vision. They have the ability to actually call out and use tools. And to do that, we'll generate those and triage CVEs. So AI-assisted SecOps, this is pretty much what's going to be the future moving forward. It will, I don't know how else to put it, it will replace some of the early junior analyst jobs, because it's going to be detecting these things faster than any human can pull in and do the correlation. You know, in the old days, we had all these separate logs on all these different systems, right? And that was kind of the idea behind something like Waza. How many of you guys have actually used Waza or teach it in the classroom, or at least teach the concept of it in the classroom, or have possibly used Security Onion in that fashion, which is not specifically Waza, but the concepts are the same in terms of logging? Security Onion, okay. Do you guys teach any active classes on log management and pulling that stuff in? Okay, primarily Security Onion, great. Okay, so that, I mean, when it comes to the cybersecurity side of things, that's probably the number one analyst job, is being able to understand these logs. And it's great to be able to do that. We give them some sample logs or something like that, where they got to go hunt through and figure out what happened. But standing up a real live environment for them to see actual traffic go across there, understand what it is, because most SecOps is also NetOps at this point, where you're seeing not only the traffic that goes through there and monitoring it, you're having to raise alerts and flags. And the job, because pure networking has gotten fairly easy, other than physical manual deployment. We haven't found the robot that goes up and puts an AP in the attic yet for us. But at the same time, we need to have those skill sets. And if I'm getting that information from employers, they're the ones that are calling saying, hey, make sure you're covering this in the classroom, because we're seeing that some of your graduates don't have XYZ experience. And a lot of that is, as you guys are well aware of, the students don't go out and try to gain experience outside of the classroom. So hopefully we can get a couple of these in the classroom without going over the top and putting too much pressure on our side, but it's fairly easy to do. But that AI assisted side will definitely take over some of those junior analyst jobs. And the only ones that will survive are the ones that can work with AI in order to do their job faster and better. So if they want to be marketable in this place, they need to understand the AI and the technology underneath the hood. And if they're the ones that can help implement that into the SecOps, if they're an existing employee, they will be the one that stays as opposed to the one that gets folded into the realm. So where it really helps the most is everybody drowns in volume. I don't know if you've seen these kind of logs that come in, but there's so many false positives, and we teach about alarm fatigue and everything coming in because there's just a constant slew, and we have to figure out whether those are real or whether those are false. And tools like Waza or Security Onion that packages up a couple of these together, you usually have an elk stack for that, will collect all these logs from all these different systems and put them into one database. And then it will try to normalize that data by able to do correlation between things. So everything generates a different style log. We try to normalize that into a standardized log format so that it's much easier for us to do those correlations. In the old days, you had to be a person that could do that correlation. Now we can do that very, very fast. We can have it look through the logs and reproduce the scenario. Um, a great example of this is some software that I was developing here recently with mobile apps and a web interface. We put full blown end-to-end testing in there, but we also made sure that we were logging all the keystrokes and every move that was happening on the mobile apps. And now, if there is an event or an issue that comes through, we're alerted before that user could ever submit that issue to us. And the great part is we can see exactly what they click through all the way through. Where that applies on the security side of the house is I can now see what triggered what violation, and we can see the clicks as they go through. It gives us a very fine grained amount of data coming back. And it's all to make the system better. If we can catch those alerts before the users have to report an issue, we can push it out in the next patch. Or in this case, a way I do that a lot in software development is in the bottom right hand corner. I have it to where they can submit feedback. So if something comes up on the screen or they don't know what's going on or an issue on a certain page, they click on that feedback. It instantly takes a screenshot of whatever's on their screen. It will then add any additional notes it knows on the back end as metadata, allows the user to type what they believe the issue is, and then that gets submitted back to me. Instead of me having to process all those tickets, I have a constant AI that's sitting there looking at those for incoming tickets. It scans those images, goes back, references the code, determines whether or not there's a real issue or a bug or something that we should tweak in order for that to happen, reports that status to me. And if I give it the approval, it will go ahead and patch it and push that release long before we have to wait for a software release update, which means the dev cycle and the return on bug issue reporting and such is literally within hours, if that, and we can get those bugs fixed right away. So you can imagine to a client what that means versus having to submit tickets or trouble tickets out to an old school vendor, and those tickets take 2 to 3 days to get it. And then if it is a software patch, it could take a couple weeks to get that fixed. That's kind of the beauty of AI. It will definitely assist in that, and we can do that same thing right within our SecOps and our security operations center. So as it shows here, we can summarize those logs, draft any kind of detections that come in, and then prioritize any kind of vulnerabilities. That's probably my favorite thing that I do when I've used it in this fashion is give me a list of priorities based off what we've triaged out of the logs. And that way we can tackle the hard stuff first and get our small wins. And then we can kind of work on to the bigger stuff in here as well. Hey, G, no problem. I'll get you marked in. Give me just a second here. There she is. Okay, no problem. So the next piece that I really wanted you guys to kind of think about, and I know I asked a little bit of this question yesterday. Most of you, I'm assuming, have worked with a chatbot style of inference, right? So you've worked with either ChatGPT or Gemini or Claude in its chat-based form fashion. So something that you might have seen looks like. Well, I had a nice screen up here if I can find it again. Looks like it disappeared on me. So most of you have dealt with something like this, right? You get your screen and your terminal out here in the middle, you chat, and you can see all the different chats and everything I've used in this kind of system. I'm guessing most of you have worked in that. How many of you have actually worked with the coding agent? And I know I asked that, but I wanted to check in because today we're going to be playing a little bit with that side of things. So that would mean something that is straight in the Claude Code side. So if we look at this, you've probably used this Claude Code style interface if you have. Or the Codex version of this, which is great. And also probably even an open code version where you played with those different backgrounds and ways to interact with that. Has anybody played with open code and used other LLMs in the background? Just Codex? Okay. So the main difference between what I do in something like this one versus what you do in the other chat is in the chat, it doesn't have a lot of context if you want to work in terms of files. So you could upload those files, give it questions, that kind of thing. But if I use a terminal-based approach with the CLI here, I can give it access to that folder, and then at any time it can use that to look up different records. It also gives it a place to store memory in there, which some of those online ones are now adding that feature. Most of them have it. And then some of them even have a desktop type approach too, right? So for example, Claude has a Claude desktop style application. See if it pulls it up here. Looks something like this. So it looks very similar to what you see on the online side, but you could come in here and interact with it. What's nice about the desktop ones is you get a mix of both. You get either the chat sessions or you can deal with the Claude Code side where you could select a folder you're going to be working in and then start asking questions about the files in that folder. You also have the ability to work on these kind of things remote. So for example, if I'm in here working on this session, I leave my laptop up and going or desktop up and going, I have remote control turned on, which means I can go to my phone and I can continue this conversation over here. So this is where they tell me I'm supposed to put the laptop down from time to time. Doesn't always happen. I walk away. I need to go to an event or something where I can have my laptop with me. I can pull up my phone and keep that conversation rolling at the same time. Those are kind of newer things that have come out in the early days of this. And I say early days back in January. I had built some third-party systems to do that. And that way you could keep ongoing sessions going. What's great, and the whole point of this side, is you can build out a plan. You authorize that plan, double check the plan, and then you tell it to execute that plan. In this case, I call it ship now with Claude. And then you kind of want to just check in from time to time because if you build out a really good plan, honestly, that agent can go off and fire a lot of things before it ever runs into any kind of issues. So being able to check in it, keep it moving, but then also fire off multiple agents. It's a really cool process if you've ever get into the coding side of things. It's great to ask regular questions on too. Probably one of my favorite things to do, and I even do that here in these Claude Code sessions, is I'll start asking a bunch of different questions about whatever it may be, or I start doing a bunch of research. And then the best thing I found here is they have this concept of called artifacts, and that will build some kind of display or a file for you or something. What I've always done is I'd say, build me a standalone HTML file that houses all this data and displays it. And the beauty of doing something like that is now instead of having a PDF document that I send to a client, I send them a simple HTML file. I don't have to have a web server running it or anything else. Everything's all standardized into that one thing, but it makes it interactive. So I can add photos to that. I can make it where they can click or they can see diagram workflows of how data transitions from one piece to the next. It gives a really rich, think of it as a rich interactive PDF type style format that any browser can open and use. That's a great way. So even if you're using that chat style, I encourage you to use those artifacts. ChatGPT can do that. Claude can do that. All those tend to have those abilities to do that now. So with a plain chatbot, it's a single move. You put text in, you get text out. You can't really look anything up. We start to do a little bit of that with RAG. An agent is that same model. It's just placed in a loop with some tools. And those tools can dictate how much it can really pull. So it has the ability then to reason about whatever tasks that you gave it. It has the ability to act, in which case it calls a tool and reads the alert, looks up a CVE, runs a validator, whatever you may be asking it to do. In some cases, it may be just loading up a file. It may be executing any kind of script in the background to get information, or call out other tools like MCP servers that we're going to be talking about. We'll observe that tool's output or whatever came out of that tool. The AI can do that, and then it will repeat and continue to go until it gets the answer or the result it's looking for, and then return that back to the human. So the difference is really in ground truth. A good example of that is a chatbot, and many of you have ran into this. If we ask it about a CVSS score from some kind of training, it may very well hallucinate it, right? It all depends on what its training was at the time that model was made. If data has changed or steps have changed or menu has changed, then it's not going to have any of that information. In an agent style, it's going to usually fetch something from a data set and then reasons over whatever the real number is or how to get the actual information. And everything we do in Day 4 build here is going to be agentic in that sense, and that a model will do the reasoning, a tool will provide the facts, and the loop itself, not the model's memory, is what makes the output a little more trustworthy. So if I'm going to ask it about CVSS scores in an agent style, it will typically go out, pull the latest CVSS records from wherever it pulls those records from. There's multiple places to get it, NIST or wherever else. Pull that back, iterate over that, and make sure that it has the most accurate data that it comes from. Now, obviously, we have to depend on our tool to be able to pull the right data, but that will certainly get us on the right stretch, and make sure that we're getting real good data coming back. So those tools are how the model stops guessing and starts working. And you got this loop, and there's a bunch of different loops in there. When you talk to agentic programming, it's talking about a very simple loop where it just checks and validates and gets you the answer. In more recent months, I should say here, or more recent weeks, they had the idea of loops that would do this on the coding side and never let you out of it. It would just stay in that loop to reiterate, and get that final answer. This became fantastic on the coding side because it would just keep going. It wouldn't stop and ask you questions or invalidate things. It would do it in a more automated fashion and do multiple variations of it. Nowadays, that's kind of baked in. So all your big frontier models have all of that in, but it used to be a third-party process that would help with those iteration loops and kind of keep it stretching out forever. It was great. Very, very complicated in the early days. Nowadays, it's all nice and baked in. So with each tool call, it's a scene that you can inspect. We can place check permissions. We can validate the output. Remember, because it's not in context, they can't pull that data out directly. It has to call that tool, which means we can put checks and balances on those tools so that we're not releasing any information we shouldn't, which is basically everything that we learned yesterday. A chatbot, in that case, again, has no scenes. It's just emitting that stream of text or that single string of thought. And an agent is nothing but seams, and that's exactly why AI drafts human decide is enforceable here and not merely a slogan. That's, as you see, as I'm processing. So again, when I have a chatbot like this one, you'll notice that I have auto mode on. And if I turn that off, back into manual mode, then at that point, it's going to start asking me questions for anything that goes through there. It will go so far and then stop and ask for questions. And that is really good. You don't want a, quote, fully automated system. So you usually got pretty scared having something like auto mode on, because it would just iterate. It may be going down an entirely wrong path. And at that point, it's either A, burning tokens, or B, changing a lot of code under the hood that you didn't really want it to touch and work with. So in the old days, they had, again, what was called a GSD framework. That is what I use the most. Get stuff done, replace the S with something else. But that was what they called it. And it really worked. What it did was just a methodical way of going about software development. You went through a plan phase, a research phase. You went through a couple of other ones that are in between there. It's been a while now since I've used it. And then at the very end, you would go ahead and do an execute phase. And at that point, it could go ahead and kind of automate through. It was great because I kept in touch with every single step in the way. I could make sure that it never went down the wrong path or got too many permissions, which is part of the rot that we were talking about yesterday. Um, Nowadays, like I said, they have that kind of baked into the frontier models. So Codex has that built in. Uh, Claude has that built in. So Claude uses what's called /plan. And you can see that there, and it will go through and write a full implementation plan of how we're going to do this, almost like a run book with a bunch of different phases inside of there. You can see my old GSD stuff here. So if I type in GSD, most of that should have been removed, but you would see ways of doing planning. You would set up milestones, and that was kind of the best way to iterate with some of these. That was honestly the reason I kept it the most, was it would take whatever your project was, break it into milestones of what you wanted to accomplish. Then for each one of those milestones, you would get plans. And from each one of those plans, you could go ahead and have little pieces to execute. So it really broke it down in a nice methodical way. You could stop it at any point in time. But he also had a checklist at the end as to whether or not you got everything done. And that is where, like when I built a project management tool, I could then import that in, assign costs to the different sections that were in there, and then I could bill out. Or in this case, you could go back and have a nice detailed history of everything you did. And because it's committing each one of those minor phases out to a Git repository, if you have it set up, you could actually recreate everything that was going on. It's a great way for troubleshooting now. And it doesn't matter how small your project is. You don't have to write full-blown software apps to take advantage of Claude Code. I would argue that even if you're just going to sit there and talk with it, just like you do in the web browser, that still doing that in Claude Code is better, because now it has the ability to write files and build visualizations for you, that kind of thing. While it can be done in the web interface, it's a little clunky to get that stuff out of the interface later down the road. So that kind of brings us to our MCP servers. So just as a branch here, I'm going to look. If I do a /MCP here, I can see the different MCPs that I have set up on this particular project that I'm using. So that could allow you to connect out to, say, your Gmail or your Google Calendar, your Drive, even the Claude and the Chrome app. What that allows me to do is work with a particular tab in a browser. It'll take a screenshot or try to click through it. Other great tools that are in that is one called Playwright. So if you are writing code, it actually tries to click through every single button that you have, double checks everything. It's really good on the testing side of things. But MCP servers, you notice the other ones I had here was Higgsfield. We talked about that one. That Higgsfield is just a communication process between Claude and the Higgsfield website. So instead of me having to come out to the Higgsfield website and actually build out the different images or videos, that MCP allows me to do that. And you'll see this is one of many here, but we have the ability to have this MCP inside of here. We also have the ability to use the CLI. And there's two different ways on how that works. So for example, this does a great demonstration of how we use this with Higgsfield. We can say, hey, here's my product shape. Here's what I want. Generate this 15-second video, and it will go ahead and do that. And then it will do multiple iterations of that so that you can come out with a nice little marketing video on the outside. I've also used it for explainer videos. So like this one where you tell it, hey, generate how fire was made. You get the nice little subtitles and the text in there, and it does this really, really fast. It's great for building that. On websites, I do the same thing. So I build some really cool interactive websites here. Let's see if I got a demo of that one, just so you can see the changes there. And again, this is all relevant when we get in there, because as you guys saw yesterday, when we go out and look at our resources page and our SOC, I was able to use that same MCP to beef up our documentation and instruction that came through there. So we have this one here, and then as you get into the infrastructure as a code documentation, which looks like here, this was able to build out more detailed graphs and diagrams. And as you guys know, that's a little more complicated to build, but if it can read it from the code and then generate these on the fly, It's best for your students. They can do the same thing with the logs. What I've always liked it for on the log side is you could build a visual representation of the attack if it happened. And if you've seen a live SOC, which was probably the best thing I was able to do with my students last fall, is they were to do an install of a SOC. We talked about that, kind of what we're doing here today. But we were fortunate enough to take them to a live SOC in Colorado, where they service about, I think, 30, 40 companies overall. And they were able to sit down and see what it looks like to interact with that SOC, what the different tools are. And it was literally the same tools that they were using on their side. And so that was a great experience for them to see one in action, have the ability to actually be hired. They were hiring interns, kind of thing, where you could do some testing and work remotely to play with all those pieces. And one of the first things they had them do as interns was document stuff, document the incident and try to explain that as you could. And then, of course, during a major attack, you have to inform your board members, your CEOs, all your chief officers. The more visualizations you can give them so they can understand it, because they don't understand the technical jargon. That's not their position. That's not their job. You could utilize tools like AI and these MCP servers to help build visualizations for what they may need to see on the inside. So obviously the video stuff wouldn't be the same in that, but this is the same way. So if you want to use Nano Banana to do that, and then you can see how it generates additional images. Clearly done on the marketing side here, but it's still very much applicable to what we're trying to do on this side. All right, so what is an MCP server? And I'm going to pull up one other list here just so you can kind of see what another project would look like. So here is another internal project that I use. This is part of that Ops IQ we were looking at, where I have built out my own MCP servers. That's kind of what we're going to do here today with some other things. And that would be like my Ops IQ. So it has up to 62 tools that it can call on just by using that particular MCP server. Quotient is what I use as a project management system. It helps me build out quotes for building software, and estimates the hours based off the things that I've already done prior. Also with AI technology, what it can do in terms of speed. So it's a slick tool for building software development. And then of course I have a Unify one here too. So a lot of different places will have APIs, and those APIs are okay, but you still have to figure out how to interact with those. One of the products that I use the most with a lot of clients on one of my companies is the Unify suite. So whether that's the routers, the switches, the APs, the door access control, physical security on cameras, etc., all of those we install and set up for people. By building out an MCP server, I could actually help the automation of that, and even more, I can use it to retrieve logs and determine issues. So one of the biggest things I troubleshoot is a large Wi-Fi installation. And that Wi-Fi installation covers an entire campground. And on that campground, there's about 500 different access points there because of people driving in with campers and their own Wi-Fi. And then you have houses around that region. There's just massive amounts of interference. With that MCP tool, I could sit there and pull logs and be able to push that in. So it's a great tool. I've also had it now where if I need to set up a new stack of equipment, I get the basics of the Ubiquiti side set up so that I can get the MCP tool to talk to it, and then I can run through configurations. It essentially turns it back into infrastructure as a code. And as you've seen, I'm a huge fan of that for consistency. So every client I go to, I can make sure that we set all the right settings, everything's consistent, and then we can go back in and spot check things that we need to make tweaks for that individual customer. You can kind of do that with configs, but you risk sending other credentials or other people's configs in there, and it's kind of a pain to do that, where this actually just configures it on the fly. Johnny, yeah, I know that one still needs a little bit of work, but I'd be happy to post it out there on GitHub and try to throw it under that resources link. Yep. It's very limited as to what Ubiquiti offers in their API. That's grown tremendously in the last year here. And it relies on their API. It also relies on, if you can't get the API, if you can get SSH access to the individual device, then it can execute some of those tools against that as well. Okay, so I've shown some examples of MCPs and things that you can use there. Here's what an actual MCP is defined as. And so it is an open protocol that standardizes how an AI application connects a model to external tools, data, or any kind of context on the outside. So it's just a protocol for speaking between these different interfaces. So instead of a bespoke glue for every single integration, a model speaks one protocol and then can talk to any MCP server. So the idea behind this standardization is without a shared protocol, every application and tool pair would need a custom integration back to the actual model. So it's that classic N times M problem where M applications each handwriting glue for N tools. And that MCP kind of collapses that down so that once we write a tool, it speaks an MCP language and we can speak out to the end client, whether that's your Claude desktop, an IDE, your own little runner, which is what we built, by the way, in our little Docker container setups, that kind of thing. So a server will end up exposing three kind of things behind one interface. It exposes the tools and the functions the model may call, lookups like lookup CVE, resources, data it may read, or even prompts for reusable templates. That entire pitch will write the integration once, and then we can use it from any client. So another way that I've used this kind of thing with a client is we jokingly created a chat bot called Ask Easton. And that was one of the employees. It's the owner's son there. The idea is that they could ask it questions about a data in their database. So it's a really simple model. As a matter of fact, under the hood, I believe I'm using Claude Haiku because it's very cheap. I don't need a very high-end fancy model whatsoever because all it's doing is routing requests coming in, classifying them, and picking the correct tool in order for it to execute, which means I don't have to pay for a high-level inference every single time somebody asks a question or interacts with that chatbot. And that's because of MCP servers and being able to generate those tools. So if they ask a question that comes up and it doesn't know how to answer it because it doesn't have a tool for that, I have it where it automatically logs that question, logs what kind of tool we should be building. And just like that feature request thing I was talking about before, every morning that tool goes in, determines whether or not we actually had tools for that or something went wrong. If not, it suggests all the different tools that we should add in. I approve those and add them into the chatbot. And it's a real quick iteration that, nope, I can't give you an answer today. Let me check back and see if I can get a tool for that. We generate a new tool, and now we can have it answer those questions. The cool part is you build up all those tools, and now that works great for that little chatbot. But under the hood, I can use those same MCP servers to execute with Claude Code if I'm trying to make changes to the code or I need to do a quick lookup of something. Instead of me actually having to go to the SQL server, generate an SQL request, pull that data back, clean it up so that I can use it for my model, I already built that MCP. So it's a build once type of thing, and then integrate into everything that you need under the hood. So this lab is going to kind of target a 2025 MCP specification. That's kind of a standard one in there. That's what most of these will use. And again, you can use something like Claude Code to build out your MCP servers. That's what they want you to do. Same way with skills. When we talk about skills in a Claude Code style environment or an agentic environment, I think the best explanation I gave in the past is it's a lot like watching The Matrix, where if you need to give it a different skill set, you simply add in a new MD file, very much like she did with the explanations of the different VMs. So you'll notice she has this all as MD files. It's very similar in what Claude Code will end up doing is saying, hey, this is what you need to add in. It's stored in an MD file. It reads it in and then pushes it out. The idea here on this side, if you haven't seen skills, which I could pull up that here as well. And this is where you don't want to load too many skills up. We talked about that, where you have too many permissions and too many skills in there and they can run off. But by default, there's a certain set of skills that I leave logged in on every single one of these. So you can see here that if I'm doing backend development, it keeps API design principles. You go look at that skills.md file and it makes sure that you follow XYZ standard. Or CI/CD pipelines. There's a bunch of different ones that I always have running. especially in the security scanning. So if I'm doing testing and stuff like that, it's going to make sure that it holds it to a standard or at least runs a scan against it every single time I run it. Now, the more skills that you load up, as you can see here, those are all classified by tokens. So just in skills alone, I have 114 skills on, and I actually need to get rid of a bunch of these GSD ones. I can see that's burning up my tokens every single time. But it has to load all those tokens then into context. And so the more skills that you load up, the less space you have in your overall context. How many of you guys have played with the skills and stuff in here? I know a couple of you said Codex and had played with Claude Code. Do you guys play a little bit with the skills and have added those features in? Or maybe even written your own?
Unfortunately, no.
Okay. There's some really cool skill packs out there that are available, even the ones from Claude, or I'll try to find the reference here to one that I use, which is a lot of the ones that you see listed here. Works really well. It basically gives it a whole new skill set. So most of those come in with plugins in here. So if we do a plugins, and that's where you get these ones here. And I should be able to pull these out here, but you can see you give it a plugin like Playwright, and that will help me give browser automation from end to end using an MCP server. You can also have Ralph Loop. That was that loop I was talking about before, where it's an interactive self-referential one. It just keeps iterating over and over till it gets the answer it needs. Man, there's a lot of them in here, and I was looking for installed and see if it had any of these other ones in here. Marketplace, that's what I was looking for. And so this is this top one here. If you were to take a screenshot of it, that is the one that has a lot of those workflows inside of there. So in this case, if we were doing this for, say, our SOC analyst stuff, we may very well want to come in and do things like error debugging and error diagnostic skills, where they have written MD files that are designed for specifically doing that type of skill set. And these are shareable. You can share them out with somebody else. You load it up in the system, and now it has that skill set. So obviously, you want to be careful where you get them from on the internet. You would like to make sure that they were posted, because those skill sets, you know, if somebody wrote a nefarious one, it could be sending information back, etc. Okay. So in our lab, we're going to end up having an MCP server that exposes two different security tools. And those tools are a triage logs, with logs being passed into it. It's a very simple rule-based log classification system. It's either offline, it's deterministic. Remember when we talked about that on day one, this is a very small one in there. And then we also have one called lookup CVE. And that idea is that it's going to go do a CVE lookup from a bundled data set. In this case, it's all offline. It's not actually going to go look online. We could do that. Note that I wrote it in the lab specifically so that it would all work offline without internet access. Right. The demo itself will end up showing a full tool call round to round. So a natural speaking language task goes to Quinn 2.53b with those tool schemas. The model is then going to return what's called a structured tool call. The runner executes that against the MCP server, gets the result back, feeds it into a grounded final answer, and that whole round trip is where the model will reason, call a tool to get the truth, and then feed it back. And that is the whole basis between agentic security tooling. And I mentioned this a little bit. We can do that demo here real quick so you can see what I'm talking about. Just skip down here. And here's our MCP for SecOps. So let's just download that for today. Okay, just like most of the other labs we've done, the first thing we want to do is Docker compose up -d. This is going to take a little longer here as it's got to build out a little bit more. So that should be good. Now we need to run that pre-stage. So if we do an ls, you can see we have that pre-stage file. So bash pre-stage. That will make sure that we've loaded up the correct model. It's going to launch our MCP tool, and we'll go in and look at those config files so you can see what those MCP tools look like under the hood. So other examples of MCP tools, you can build one out for Proxmox. Proxmox, I think, has one officially, maybe now. If not, I've always just built out the ones I want. So even if an official MCP tool is out there like Higgsfield, that one I'll go ahead and use. If I'm doing one with, say, Wazaa, or maybe I want to do one with a log server or anything else in between, I tend to generate one. And the reason I do that from scratch is it only has the tools that I want it to be able to do. So I can limit what it has restrictions to, or how it would build out. Plus, I know it works in my lab environment. Now, yes, that requires a little bit of tokens from the Claude environment, but if you're paying for a monthly subscription or something, it's not too bad. It's worth your time to have those very finite to your particular organization. So that's exactly what we're going to do here later today with Chi setup. We're going to build out some MCP servers that would allow you to interact with different tools, so that you can pull that information back out. Okay, so we have that one there. It looks like it's all set up. We'll just double check and make sure the Docker Compose is running after we did the staging. And then we're going to run that Docker tool call. And you'll get to see this step by step how it does that. So we set up a user task, aka we asked our MCP server, which is again a local Ollama server running Quinn 2.53b. We tell it that it has an MCP server connected. It has two tools available, triage logs and lookup CVE. We then say, I'm reviewing a vulnerability scan results. We noticed we have this CVE on our OpenSSH servers. I want you to look it up and tell me if it's an urgent patch and how we should do that. And so at that point, that tool goes and looks up at a local database that we have set up offline. Otherwise, that MCP tool could be going out to NIST and all the different places to retrieve that information. And then you can cross-correlate that. So one way that I've done this in real life is with a company that I manage their firewalls for. They run a little bit of Palo Altos and a little bit of OpenSense. And so I try to make sure that we're always up to date on our CVEs and our patches. And if you've ever used Palo Altos and stuff, you know that that's complicated. You can't run the bleeding edge because it's just too bleeding edge. But we want to make sure we're never vulnerable for those CVEs. So I wrote some MCP tools that would do just that. It would go out, find the MCPs or the CVEs that were vulnerable to the versions of the Palo Alto firewalls that we run, as well as OpenSense boxes. It would then report those back to us as a database, and then it would truly try to almost exploit those to make sure it was truly relevant to our situation. And then it would then report back to us, here's alarms or things that you need to do in order to resolve that. The beauty is it's never cached. It's always pulling the latest things from Palo Alto, from NIST, from all the other security bulletins that come out. It correlates all that information together so that it's not just guessing off one little CVE listing on the offline. But we can see what it did here. So it sent out that request. It's going to have Ollama call the model, see the task. It says, oops, I'm going to use lookup CVE. It then goes out to the MCP tool, and that tool is just sending us formatted information. So it would look something like this. It pulls back the ID, the CVS score, the severity, the description of how it would work, what systems are affected, et cetera, et cetera. Then the second Ollama call will look at those results and formalize that into a natural language, because that's what our models do. And you can see here, it gives us a much better detailed description versus what came out of this side. So, yeah, Johnny, that was one thing. I run a Palo Alto course, and so I'm trying to get some extra tools there that would demonstrate that, along with, I've kind of split that course to teach OpenSense as well, because only so many employers can afford the Palo Altos. So we want to make sure that students can understand, here's the Cadillac of the versions of firewalls, but you can do some of the same concepts on these lower end firewalls and you can implement that for maybe a smaller medium business that can't afford it. But you can build the tools so that you can make it feel and act like a Palo Alto type scenario. And that's really what I've been pushing on the last 2 years. And I think students are starting to take note of that, especially now with AI. The ability to build those extra tools is a whole lot easier. Before, they were required to take my advanced Python course, which allowed them to build quick websites. And by websites, I mean web apps in there. And so one thing I did, just as an example on the Palo Alto in that course, was we would have it comb through all the logs and find all the logins that are coming from other places, especially if anybody knows Palo Alto's, the global protects are like targets. They're just a magnet for people coming in trying to break into your VPNs. So we would take all those, we would then build a blacklist of all the people that were attacking within about 5 minutes. If there was multiple attacks within 5 minutes, I add them to a blacklist. And then we could feed that blacklist back into the Palo Alto itself. They have the ability to use dynamic lists, but you can only do so many injections of IPs that way. If you use their API, you can actually inject it straight into the firewall rule itself. So not even in the UI, it's literally injecting it into the firewall. You can put in millions of records at that point. So this little bit of Python software we did in that class would allow you to generate those lists. It would check it every morning and then feed it out. And then now with AI, we can build those little websites really, really fast. So I could make it not only build the website, but it would also pull map information, do some GeoIP information so we could figure out where those attacks were coming from the most. And we could just put in blanket rules to block those locations. It was a great way for them to understand that having a little bit of software development skills, not super high end, but just enough to build very simple web apps. Those were Streamlit apps, which if you've run Python and Streamlit, they're very, very small little Python files that you can go. They could take that information and build a little website demo for their boss to explain, here's where we're getting attacked from as a visualization. He could literally click over in China, see the breakout, how many attacks were coming in, and then what we were doing to resolve that. And I guarantee you walk into those chief officers' rooms with that information versus an email or a PDF that says we're getting attacked from here, you are much, much better at keeping your job. and these students love that. They love the idea that they could come up with some very creative ways of showing the exact same data. And I see that being applicable in what we're doing in this session today by combing through logs and building visualizations that way. All right, I apologize when I run off on side tangents there. So if I'm falling off track or losing anybody, by all means, stop me or slow me down there. So we can see in this response here, that's the whole idea behind this MCP tool is we store little data. This is probably set up as a little database. It's emulating that right now, but you could say that we have our own little, say, SQLite database that has all the different CVEs listed in it. And we have an MCP tool to do quick lookups and retrieve that information so that we know that data is consistent. And then it will go ahead and format exactly the steps we should be doing. So when it looks up the mitigation steps, we need to upgrade to this, enter a measure, we can do this. And then honestly, the next step is you can feed this information right back into something like Claude Code that has access to your infrastructure. It can do a dry run on this to test to make sure that this is actually the way we should be doing it. If the dry run succeeds and we do an end-to-end test on it, you could then go ahead and schedule it for the next upgrade and do the upgrade later that evening. It sounds really scary, especially if you've ever been a manager of infrastructure in that realm. But when you understand the tools like this that run, it becomes not only less scary, you actually trust it more because it's doing more tests and more things that you wouldn't have time for normally. If you've ever done operations, you know that if you're lucky, you can do some testing. Otherwise, you just have to point and click and hope it works. And if not, revert back. That's the beauty of this. When it builds a run book in here, based off these kind of tools, when I do infrastructure upgrades, for example, it will run a test example of it, make sure it works, and then it builds in so many additional tests and fallbacks. So if I'm tweaking a database or making the changes under the hood, for example, upgrading Proxmox, lots of things can go wrong. And in this case, it always gives you those build back and ways to revert back as long as you bake that into your runbook. Okay, so that's kind of an example of what it looks like to do a very simple MCP call. The next one there is where we're going to get into some detection and stuff. So I'll pause here. I think we usually break at 10:30. Is that right? I know that was a lot of information again all at once. Is it 10:30 or yeah, it'd be 10:30. So we'll take our normal 30-minute break here just so you guys can catch up. I'll see, is there anybody I missed on the initial check-in here? Pause the recording. At different customer locations. So when we were choosing the next router that we were going to deploy at customer locations, we got to run it through this Ixia, and that worked very similar to like what Terry's showing there with HPing, or if you've done any packet, just simple ping traffic generation to see how fast you can get throughput through there. That stuff works, but it's not really realistic, especially when you start having a firewall in the way. You need those various types of traffic going through, and then you could put a load on the CPU. Ixia was really, really good at that. Then the next one that I kind of played with the most was Cisco's T-Rex. I was using it last fall. It works well. It's a little cumbersome to set up, but if you give it enough horsepower, you can scale it pretty quickly, and you can generate a lot of stateful traffic through it. That was probably the biggest thing for me, was generating stateful traffic, because we can always generate the other layers, but actually getting full at layer 7, up through layer 7 traffic through it was pretty cool. This runs as a VM. It's a little complicated to get the VM up and going, but once you get it rolling, it works really, really well. It worked so well that I accidentally redirected that to the wrong firewall here on campus and was able to saturate one of them. That was the actual campus one and not the test one that I was dealing on. So it was great. It was good because they got, obviously, to check their own rules and realize some things were not in place that they thought were in place. But overall, it was a pretty good architecture and works pretty darn well. I think that project is, I don't want to call it defunct, but it's just kind of sitting there. When I did play with that, that was prior to having something like Claude Code help me assist in the setup. It was more of try it, it broke, go back to ChatGPT, type in the errors. Okay, it doesn't know what the system's actually doing, so it tried to give you some direction on how to stand this kind of stuff up. Nowadays, I would imagine we could build this out pretty well. So, and sorry, that original question, I don't know if I was recording, was traffic generation stuff. So, like I said, what I'd like to do now is build a whole new one. Given the skills that I've worked through Claude Code and building out VMs and package and software and stuff, I'd like to build a new UI that instructors could use in the classroom. That'll probably be one of my big projects this fall, because I think that's the biggest thing that we're losing for that side of it. Yeah, so Waza, to me, that was the obvious choice. It's used in production. That was one thing I did, is we took a bunch of our capstone students that were going out and deploying these in the real world, and besides the ones that were extremely expensive, Waza was probably the most popular one that went out there in terms of deployment for log stuff, and also just doing a full-on XDR platform. This one seems to win out. And so I've deployed this now at Fort Hays in the test environment, deployed it at a couple businesses. A lot of the clients, I work with a MSP, and they're starting to deploy Waza as their main focus for bringing all that client data in for monitoring purposes. So, and it will start in a real small solution, like a one box type setup you can do in the classroom. It works fairly well there. Or you can have, the basic installation where you have your indexer and your database and your main GUI system and 3 different VMs. And that's what I had my students deploy in their SOC last year, was literally doing that. And in Cheese deployment here, that's kind of what we have as well. So you have the Waza setup. It's kind of an all-in-one box there that puts it in. Yeah, and like I said, her setup that she has in here is literally what's been set up with all the templates and everything else, and it's still crunching away on all that. And I think the last thing it's doing now is we're building a little box for as a jump box. So when you go to configure these, in this case, again, I'm connecting to this via VPN right now. That gives me a little limitations as I can't reach all the way into the VMs. I can reach on the outside, but not the VMs. So if we build a little jump box in here, then I can tunnel into the jump box and from the jump box be able to hit these VMs just to get everything configured. And then you can shut down that jump box to keep us on separate networks. That way we don't have to do a bunch of routing magic over VPNs. We can just hop through and send it that way. Which, since we're here, I'll just do a quick status on this, and then we'll jump back into our content here before we go to lunch. So we are to the point where we, again, have all of our templates set up. Those are all pre-configured, ready to go. You guys will be able to build those or even download those directly. If they are the Ubuntu side, I will be able to find a way to export those. If they are a Windows one, I can't legally do that. So I will get you the script files, which is basically the tofu files that'll help build that out, the Packer scripts. Those are now been fixed, so you don't go through all those issues that you saw me go through yesterday. Those Windows Server and those can still be a little finicky, just because they have to use sysprep, and if anybody's ever used sysprep can be finicky. It's really a timing thing. But we've gone in, we've set some pretty good hardening stuff in there when I was going through all those issues last night. So you should be able to build those out, and that will generate these VMs that you see over here on this side. And once we get those up, which are just to the point where Ansible is now logging into these and running the scripts to configure them. And that way it goes to the spec that she had in terms of, for example, if we go to this domain controller build, it's making sure that it's set up exactly in the specs, that portion of it, but also how she has the IP, the actual domain space, all of that's being set up automatically with Ansible going straight to those particular machines. So, okay, so we'll let that run here in the background. Like I said, it's still going through, making sure that we'll be ready to go here after lunch. We can start doing some demos. The only things I did add in there is, let me go out to her branch, which we are there. Might need a refresh. Give me a second. Is this AI section, and the idea is it now has the ability for AI assisted work and working in this SOC. So the idea is that it will have a VM that's running a Llama, just running off the CPU side. That way we don't have to have any AI key, no data ever leaving the floor, that kind of thing. And it's just enough so that it can run our tool calls and still have an embedder. And it will then be able to pull the data from our insulated or our SOC environment that we have set up specifically from like Waza, et cetera. And then you can use it to ask questions in front of the Waza stuff. So we can do Waza alert triage where AI will draft it. The human decides what we're going to come out of it. And same way with rule detection, we can generate, repair everything else through the actual AI box that's on the system. So sprinkle in a little AI based off everything we've learned here today. All right, let me grab a drink here and we'll wrap this part up. All right, so as I mentioned, MCP is just one way to be able to do this stuff. CLI is kind of the latest and greatest way of doing that. And so there's kind of a debate, which one's better, which one's not. And it's really not, there's one better than the other. It just depends on what you're trying to do. So MCP is not the only way, and it's not always the best way to give agent tools through 2025. Many practitioners have swung towards a lot simpler tasks and just letting an agent use a command line. So it's worth understanding that trade-off because add an MCP server can become a reflex, and it's not always the right choice coming through. So a good case for a CLI is that a model has seen an enormous amount of shell usage during the training. So it already knows things like grep and JQ and curl and git and all that kind of thing. And there's no real schema to define or maintain that. CLIs compose, what that will do is pipe one command from another to another and then kind of pull that information in, which is a fixed set of MCP tools does not do naturally. So again, an MCP server has to be running. It has to have access to the data set under the hood. But if we want to run multiple chain commands to kind of clean stuff up, it really can't do that by default. We would have to bake that into the actual tool, which means we'd have to reproduce it. So the beauty of a CLI is they're very inspectable and reproducible. You run the command is the same that an agent would run that command. Think of it like running a script. And you would see exactly what it saw if you ran it on your own. So the cool part is with the CLI tool is you can run it yourself, or you can have the agent run it with the extra arguments and things like that. But you could always run that command yourself. With an MCP tool, can't really do that. It's meant for you to interact with it in a API style format. And so you would have to handwrite little pieces in order to get that information back out. Which drives the big reason that people are making that shift to CLI is lower token cost. So every MCP tool definition has to sit in the context window so that it knows that it's available as a command, where a CLI is just a text model that emits only what it actually uses. So if we built out all those use cases in a CLI, it can return them right back. It's just the text that's in there. We're not filling up our window. So before Claude and those went to their million token context windows, that was the big reason people were shifting away from MCPs to CLIs, is you could really saturate your token usage really, really fast, the more tools that you called in. So there was a big jump ship on that. And then, of course, when the context window got to 1 million plus, people kind of relaxed a little bit and realized, nah, I can pull out, use what I need to in that window, and do very short agent runs. So the difference between, like, for example, me running this over here on this screen, which is running that back end stuff, when I talk to this just one direction, then I have one context window, and we can see that start to fill up pretty quickly. We can see usage there. That's not the one I wanted. Context. There we go. So in my context record of this particular use state, we can see these first couple ones are gray. This is the system prompt. I should have brought this up earlier. I apologize. I never gave a visual for this. But this is my system prompt, and I'm taking up about 4,400 tokens for that. My system tools are this next little chunk that's over in here. Then I have my custom agents taking up 2 more blocks. Those are about 8,500 tokens. My memory files are only about 2.9. Now, I just cleared context. That's why this isn't filled very well. Before I do the next clear, I'll kind of bring this up so you can see the difference. Those skill sets that I all have enabled is taking up almost 10,000 tokens. Again, in a normal context window, if you only have 32,000, like the kind that you can run locally, this would fill all the context before you even got to run a command in it. So, and this is going to be important here in a second when we run this on this little subsystem. And then this last part is all the messages I've been passing back and forth since I cleared context. So I still have, a vast majority of it free. And again, I literally just cleared context before this. So even on a quote cleared context, when it comes back, I'm already using 14% of it just in all these little files. The MCP tools, we can see that I have a bunch of tools loaded, but it's only loaded on demand, so it's not chewing up any tokens at this time. So the real case for an MCP is there's no shell for us to reach for, meaning that maybe this is a hosted SaaS platform. Think Higgsfield when I did that. There's no reason for me to use or a CLI in that. I can kind of use one, but all that CLI does is basically use the MCP server side. But that's the idea, is you are using some kind of hosted SaaS app, and so you don't have a shell way to reach it. Or you're looking at a GUI tool, or maybe even a remote service that you're connecting remotely to. MCP is how you would expose all of that, and so MCP works really, really well. If you need structured permissioned access, that was also the beauty of the MCP, is I can hand out access for you guys, but I can fine-grain who's going to get permission to do which tools. In that case, the server will enforce exactly which operations are allowed and returns those typed results rather than handling a model a shell and hoping that it doesn't just pass out a bunch of credentials it shouldn't. And then last but not least is portability. One single server works in every MCP speaking client. So we just need one MCP server running in an environment with all the different tools underneath of it, and it would spit all that kind of stuff back out. So according to the AI and its honest summary, reach for a CLI when the agent already has a shell and good tools. And then reach for an MCP when you got to cross into that system that has no shell, or when you deliberately don't want to give the agent a shell access. Again, you need shell access with a CLI. You don't need that with an MCP. Both do the same underlying job, given that the model is a way to act and observe. MCP standardizes the inference side of it. A CLI reuses an interface the model is already knowing about. Therefore, the durability or the durable skill is really in the agentic style thinking, being able to reason, act, observe, and verify, and not any one plumbing choice in between there. So we'll use them a little bit both. In the lab, we'll use an MCP server here, and then we'll have a CLI-driven Sigma Suricata loop that does the event detection underneath the hood. So I'm going to pause there, and I'm going to actually go flip back to the slides because there's some extra key pieces I want you to see in that side. So going back to where AI actually helps within a SOC is being able to triage alerts, summarizing any kind of logs, drafting detections that may come through, especially when we're writing a bunch of rules, and prioritizing the vulnerabilities. So more CVEs than anybody can patch at once. We can clearly see how to do that and get some organization out of it. Let's see. We've talked about the human in the loop, force multiplier. In this case, the automation liability. So a force multiplier allows the AI to draft things really fast, and the humans themselves just spend their time on the judgment, not actually typing out the rules. Automation liability is that we have an unvalidated AI output flow that goes into production controls if it doesn't get reviewed. So we still need that man in the middle type of thing to determine whether or not the stuff that the AI is generating is actually what we wanted. So we have a model here that generates a Sigma detection rule for an incident. Based off everything we've talked about today, which rule would that come out to be? Actually, we haven't done that quite yet, but yes. You're correct. It's the B. We're going to draft that piece out of it. So let's do a little bit of that lab so we can see what that looks like when we actually do it. Skip past that and go to the draft one here. Right here. So we have a detection lab, and then we have the MCP as a SOC tool. We're going to play with a little bit all those, and then we're going to do some triage in here as well. So let's take a look at the detection side of it. Well, maybe it showed up. Oh, there we go. Yeah, I need to go in and shut down my other one here real quick. Oh, what was that first one called? What was MCP? Okay. All right, so again, just like any of the other labs, we start off with our Docker Compose up. That'll at least get those base images pulled. Then from there, if we look in that file system, we have another pre-stage. So we'll do a bash pre-stage. Let's get that a little wider. I'll make sure we got all our correct models and all the pieces inside of there. Now we are going to again use that Quinn 253B in order to do some tool calling. So that's a little larger model there. All right, so we're loaded up. We are again running our Ollama server with that particular image and that model. And then our runner is going to have a Sigma CLI. This is a CLI tool that we built out for that, which is going to do rule validation. We also have Suricata running, and this is going to check for our network rule validation with no real live capture. Again, that's in this environment. We hope to do those same things over in the real environment with real data coming in. And a little HTTP, just PyYAML, some other tools baked in, and then we have a couple scenarios that's coming in on the data side. So we'll double check and make sure all the services are running after the bash side. Looks like we're good. We are going to do a detection on the system itself. It's going to generate, validate the rules, and then repair anything that's coming through. So let's see what that looks like in a real world. In which case, this first incident comes in that we're going to fill each one with a prefix of incident number, use that as a delimiter, and the LLM is going to generate a Sigma rule for every incident that came in there. So for those incidents, if we come in here and look at our data, we can look at our incidents. We can see, like, for example, incident 1, in which case a web team reported a spike in failed logins on the customer portal. Access logs show over 3,000 post requests to that login within 20 minutes, cycling through hundreds of different distinct usernames from a small set of source IPs. Nearly all those requests returned 401s, with 3 requests being returned to 302 on a successful login redirect, suggesting that some valid credential pairs from a breach password list were found, and the user agent header had been identical across all requests. So does anybody know what this looks like? What is this scenario kind of describing? You guys are all cybersecurity pen testers. Yep, looks like a brute force attack, right? Yeah. Yep, absolutely. So what they did was got a hold of a password list, whether that was something straight out of Kali or maybe they found some other breach passwords, and then use a whole slew of different usernames and passwords to come in. They're also at least wise enough to send that from 3 separate IP addresses so that if one got blocked, it would still continue to go. However, that host 21 had found at least 3 full successful attempts inside of there. So our detection goal on this is to alert on a high volume of post requests to the login endpoint that receive any 401 responses, and especially when we receive a 302 success one. If this is valid traffic, no big deal. It logged it, right? But we want to make sure that we're getting alerted when we have a bunch of those coming through.
Jason, I missed the part where the LLM got the log file.
Yep.
Was it reading from the actual log, or was it just looking at an extract?
No, so it's reading it from an incident log, and then it comes through and actually pulls from these sample logs. So if you look at this network incidents, again, this is kind of a scenario side, but the other data is looking at our log files coming through here. So that first one, it's just a snippet of this log file to try to give us some information. Now, when we build it out, it will do the same thing. This is just kind of to give you a visual of what the tool would do.
And so when you use an LLM to do log file analysis, you don't actually have a parser or anything like that. You just feed it the binary file and it does its thing.
That's correct. Yeah, when you do it, if you're doing it just a standalone, yes, you would just feed it a raw log file and it would be able to parse anything it needs out of it because it can read through it. If you wanted to, which is what we will do, is send that through Waza, which has a true parser so that it normalizes everything to the database. Then we can use a better tool like an MCP to help correlate between different logs, not just look at individual log files.
And in that case there with Waza, we're going to be directing the LLM to look at that particular structured data set. We're not going to have it converted into a vector database.
Correct. Correct.
Okay.
Yep. That's the beauty of an MCP is we don't have to end up storing any of that to a vector or chunk any of that kind of information. It pulls it all from the MCP tool on that side.
Thank you.
Yeah. Great questions. So on this Sigma validator output, it's looking for something in that particular YAML file and looking for its contains, and it just says a rule there. What it's really looking for is these brute force attempts that it found under the hood. And so it's rewriting that rule to make sure that that condition does not get it allowed. So if we look at that condition here, we can see that any SSH brute force attempt with a successful auth that we want to trigger an auth success within our system. Again, this is setting up a rule that we would pull in. In our case, it would be Waza, but right now they're using Sigma as a way to do that kind of thing. And therefore, the rule it generates is invalid, and then it goes through and validates that rule to make sure it's valid. And when we get down here on this event set, it's now going to trigger that correctly. And then on a separate incident here, it failed after 2 repairs. So we could see we couldn't actually repair it in this particular case. A web team will end up reporting a spike of failed logins as well. Same similar thing where they're all coming in. Now we're going to have it generate a new Sigma rule where we detect those particular incidents. We can see that, again, it failed the Sigma validation rule. And then on this side, it's going to go ahead and repair it and patch it. Looks like there's a bug within my Sigma code that's in there, but it should be able to patch it. I've never seen it fail like this that many times in a row. Looks like a syntax marker that we're trying to pull out. A lot of that could very well be that this model that we're using, the 2.5, is not smart enough in the realm of generating Sigma rules, would be my guess. We pass that off to a bigger one, I would expect a better outcome there. So that is one caveat to these Docker files, is it's essentially synthetic in what it's generating, because I wanted you guys to have standalone things without having to stand up an environment. Obviously, now that we're going to have an environment, we could do all sorts of that. So let me extract this MCP tool so we can take a look at those files under that hood. That is what I wanted to show you. That's IOC dataset. So this is the kind of output you would expect to get from the MCP tool, where it gives us some nice detailed tool call. We're going to see that come out here at the top. Now for that actual MCP server, this is all the more an MCP server looks like. So I'll launch that here so you can see. In this case, it's fairly basic. We have our data system that's going to load it up so that it has access to those files. And then we can set different indicators. So we are a real fast tool building SOC MCP server that is going to provide IOC reputation lookup and any kind of batch triage over these offline data sets. So no internet. And those offline data sets look like this, which is generally JSON data. That's pretty common. Let's see if it'll pull it up that way. Let's do a text editor. And so this is the type of JSON compress that you would store in a database. Similar, this would be a flat file version of it. If we did this in Waza, it would go into the actual SQL databases and stuff like that under the hood. So we get this information out about different alerts and things, and then this tool would do lookups in this file so that none of those are all loaded up into context, that we would just do a lookup for those individual indicators. Obviously, this is a real small file. This is just to give you an idea of what it looks like. But this is how it would process that information. So we run our quote Python MCP tool. And then at that point, we have different functions, AKA tools, that would do different things. So this lookup indicator is going to go ahead and look up the indicator of compromise, feedback that information as a JSON dump, and then we would send those results back all the way through to the system, which would then look like it's in this format, right? And then we could have triage indicators doing the same thing. Again, we're manipulating the data to put it out exactly the way they want it, including recommended steps, all that kind of stuff that we're pulling out of our database. And then at the end here, you could just keep listing more and more tools in here. So an MCP server is very lightweight. It's basically in this case, like a Python script that's just speaking the language of what a model needs to do in order to call tools. And those tools in this case could be Python functions, they could be CLI commands, they could be bash scripts, they could be anything in between there. So let me fire this one up so you guys can see what that looks like. And it even warns you here up here at the top, which I figured would be a problem even with the 3.1. But if we use that 1.5 model or lower, the problem is it emits malformed tool call arguments. So too small of a parameter model, and it doesn't function very well with tool call. Generally, why the Quinn 3.5 models are the best right now if we're doing small tool calling sessions. Again, if I use, well, that's loading up here, I'll show you. So if we look at, say, API cost from Haiku, we can see it only costs me $1 per million tokens input, $5 for every million tokens output. I can use this low fast model to do all my tool calling, and it barely costs me pennies because we're using such little tokens on the backside when we have our own MCP setup. Versus going with some of these higher end ones like an Opus, I'm going to start getting charged 5 times as much on both sides. And if I was using Fable, it would be 10 times as much throughout that. So, all right, let me close a few of these down.
This is kind of a side question, but do you know what Kimi is?
Yeah. Oh, yeah.
I mean, price point wise.
You know, the places I was pulling it from was OpenRouter. See if Kimi offers it directly.
I'm asking because the rumor is that they kind of like borrowed some of their content from, and it might eventually get blocked or, put on
Yeah.
this list.
They were huge because the 2.5 one was the one that I had played with when I pulled it, and that was a while ago. It was like 3 months ago. But yes, that's the attractive part is it was cleared down to 60 cents for that same amount of input output. And then they got clear up to 3, which even then you're talking million contexts and you're only paying $3 for that input. So that's pretty if you get cache data, you're only hitting 30 cents.
Yeah.
I want to say, trying to remember, is it Kimi? Almost certain I did that through Open. Yeah. Yeah. I was using that through OpenRouter when I was playing with it. And then obviously, they have all these different providers that can come in. Of course, they all have their different costs too. So it worked really well. That's one thing I liked about Kimi. It was a great way to test some of these other APIs or not Kimi, OpenRouter. It would allow me to test all these different models and things like that you would normally get full blown access to. And they don't really take a bunch off the top, so to speak. If I remember right, they essentially add 3% or something like that for just having their services in the middle. Otherwise, you paid the raw API cost that went through there. I would be curious in this case if we could point that out to this OpenRouter. So I'll see if I still have my account fired up with tokens. I'm sure I do. And we can kind of redirect that local model to use something like that. All right, let's make sure that part's up. And it looks like our Llama and MCP server's up and going. And then we can check out the demo. Oops. And so again, a user comes in and says, during an incident review, we pulled 3 indicators of compromises proxy logs from such and such IP on this domain, triage those indicators and tell us which one we should act on first and why. And so the first thing it's doing out here is the model is pulling the task. It's looking at its tool schemas to see which of these tools it should be using. You should see it trigger the triage indicator here shortly. Hoping I shut down that other one. I may not have. Maybe not. No, that's why everything's so slow. Sorry about that. So this will take a little bit, mostly because I already had Ola running or Llama running in the background with another model, which is going to cause it not to load all the way. So see if I can stop this. Okay, that'll take a little bit, but it should burst a little faster now that the RAM is cleared up. And we can see it's definitely doing some inference in the background. Again, it's really cool to have your local LLM models and things running in there. Obviously, you got to have good enough hardware to do that. And that does keep everything local. It would also be nice to have a kind of trusted hosted platform that we could turn that over to from the classroom over. That's kind of the things that we were looking at with when I was last working with NDG, was being able to host some of those GB10s in a academic cloud, so to speak, that people signed up knowing it was specifically for this. And then you would just be able to point, we would have a API call and you would get your key and your token, that kind of thing. And you would have access to that type of environment. It would be on a first come, first serve kind of thing. And we could rate limit it so that multiple schools could share one infrastructure without having to go out and pay for full blown API costs from a frontier model. And thankfully, there's some grant money out there, especially right now, blowing up on the AI side. So this went through. It realized it needed to use that particular triage indicator, and then from this side, we can see that it pulled those indicators out of there, including the IP addresses and the domain. That information came back from the MCP tool, so that MCP tool formats it in this particular structure. Notice it's got a very finite structure that comes out. We can have that MCP tool report that in any way we want. It may make sense to have that comma separated value, tab delimited. However, our tools would consume it on the other end. In this case, the model would consume that. So now Ollama is making its second call back to the model with the results in the text field of the user side. And again, this 3B model is just screaming on this particular laptop. I did have these kind of set up and running on one of those P16s with 4090 graphics card, and I figured that would give you an unrealistic impression if you were running those on there, because like Terry said on his home one, it flat out flies kind of thing. During lunch here, I planned on doing just that. I'll have one of these other P16 set up, running the same exact setup that we're running here, just on GPU style hardware. And that way you guys could see what that would look like if you were able to get that in the classroom, the performance difference between the two. Will anybody have access to GPU based hardware in the classroom this upcoming fall? You're good, Marla. Go ahead. No problem. We'll be coming back after lunch anyway, so you're good. Gotcha, Chris. Do you know what you're looking at for the funding side? What kind of hardware? Gotcha, Johnny. Do you have any kind of budget that you're thinking of, Chris? Yeah, 100K budget will get you pretty far. So you would definitely be, well, depending on where the RAM shortages is, that kind of thing right now. For a server aspect, that should be able to get you in the strong Lenovo server range with at least L40Ss, potentially even a little higher, but you should definitely have a couple of those. And we can walk through that kind of scenario too. It looks like this crashed out. I bet it's a timeout issue was the problem on this laptop right now. I have lots of things running in the background, but we're going to fire that up on a P16 here after lunch. And that way you guys can see the performance difference of having a real GPU behind it and pushing it. Another thing I did push out on the repo last night, I think, hopefully it got pushed out there. Let's see if I can find it here. Yeah, is the Comfy UI Docker. So there's several of these out there, but I built one out specifically to work with AMD. And then you can run a slightly different Docker Compose, one with .NVIDIA, and that will make sure that the NVIDIA stack comes up for that. So if you have a laptop with a graphics card or a desktop with a graphics card running AMD or NVIDIA, you should be able to get a Comfy UI setup running in Docker. There again, I'll try to run this again with that P16 here after lunch, and that will make sure that you guys do have a working Docker Compose on the NVIDIA side. I haven't got a chance to test that, but it does work great on the AMD side. So if you come up, and that's including like an iGPU with some shared bandwidth, which is what this laptop is. In this case, it's a Radeon 890M, which is an integrated GPU on that processor. And it has about 4 gig of dedicated memory, but it can share up to 34 gig with our system memory. and therefore that fits pretty well in some of the specs that's required at Comfy UI. But yep, that repository is out there, so you're welcome to pull that out and use that as you want. All right, so that should bring us to honestly a really good stopping point here before lunch. When we come back from lunch, the idea is that we will cover the rest of any kind of models and how we do integrations and stuff. Most of this we've already talked about. I think we're almost to the point of the 2 tool calls that we did inside there. Yep. So that was one thing too, is that 3B model can handle about 1 to 2 tools. Is about the smallest model that can really handle that job. I would like to see what a 3.5 would do with a little bit of VRAM. So again, we'll test that on that other laptop here when we come back. And then the biggest thing once we do come back is we will continue to work on after lunch this infrastructure. I would like people's input of things that you would like to see either myself or Chi bring into that, so that if you are interested in using it this fall and being able to implement those little AI tools inside of there, we can continue that. This would be a huge take-home resource for the end of this lab. So appreciate your hard work there, Chi. This is definitely going to be a good feed for people wanting to get stood up this fall.
Yeah, all of you too, Chris, Chi, everybody. We need to keep in touch. I hope that Discord would be a great idea, but we need to keep in touch because it sounds like we're all doing very similar things. Jason.
Yeah, nope. I will make sure that Discord's out there today. I've started this like 3 times and then get distracted on something else.
Trust me, I get it, man.
As a matter of fact, my little Discord's sitting there spinning, and that's probably what's chewing up a bunch of stuff in the background. So I will figure out why it's not working. All right, I'm gonna go ahead and pause the recording side. All right, so coming back from lunch here, I'm just kind of doing a recap with these slides. We were able to show how we did detection. And then we got to the second one where we were able to generate, validate, and repair. Note, in our scenarios, we did not get those repaired. And let's see here. Yeah, this was to keep it fully offline. And then the CVE triage. So we'll go through that last lab here. Sock tool and this one here. Make sure that other one gets cleaned up if it's not already. Like I said, we'll finish up a couple of these labs. We'll do these and some of the anything LLM ones just to kind of get some hands-on on what we've been practicing. The lab environment is definitely working its way through. We had a little bit of issue with the Waza one, and it turned out my scripts were not auto-expanding the hard drives. So in the midst of install, it was crashing. So there again, the beauty of using something like Claude when it's doing this is it's constantly taking screenshots of what's going on the VM, feeding it right back into it. So it can actually diagnose much faster than even I can pull it up and try to see what's actually happening under the hood. But that should get us some pretty solid templates inside of there. And then right now, one thing it's working on, besides getting the rest of those VMs up and troubleshooting to make sure they're all configured, is there's a addition of a new VM, which is called the scenario VM. And what that does is allow you to launch those packet generations and various scenarios that would happen inside of a SOC environment. The idea is that it would create the logs and the traffic on all the different VMs. So it's going to send all the traffic, make it look like it's coming from those different places. Waza should capture all that. Everybody else should be sending their logs that they're capturing during that event. And then a student can then go through those logs and either use the AI tools or however they want in order to do diagnosis of that. So it's going to start off with about two different scenarios just to get it kind of bootstrapped. And then the idea is that we can keep adding scenarios to that VM in a way that if you were to deploy this, it would pull those down if it had internet access. And then a final VM that's also going to come in there is more of the documentation one. So I took that SOCDoc project that I talked about last fall. I'm going to take that code, massage it, revamp it so that it works in this particular lab environment. And that will serve as a dashboard for the class, so to speak. So that would be a place that students would initially come in when they first come into class. They would be required to document the environment. I think Chi was wanting that kind of thing, or at least wanted to add that as an addition. And it would be a place that we can actually do some testing from that VM in order to do grading. So there's a potential I can have some automated grading techniques to capture from the students and be able to have a grade book, so to speak, in there. And then the last piece I was hoping to add to this environment is kind of stretching back to what I mentioned with when I rewrote kind of a NetLab style environment with the idea that it would handle the proxy to the individual VMs so that you would not have to have a VPN type connection for the students to connect to get inside that environment, which would help obfuscate some of those VMs. And so that led me to some questions that I wanted to ask here once we get done with a couple of these labs. But to have you guys think about it a little bit, how would you be deploying this in your classroom and what restrictions do you have? So for example, it would have to be sandbox just inside the classroom and only on-campus students would be accessing it. If you have virtual students that would be accessing it, what kind of parameters or what would your lab environment look like? So do you have internet access? Do you have the ability to host things publicly there? If not, would you like to front end it with like what Johnny's saying, maybe front end it with NetLab? That would be another way that you already have something stood up that we could front end it.
I was going to ask if we don't have, if we're going to be air gap room or something like that, what's our options? But what do you mean like front end? Johnny, what do you mean by front end with NetLabs?
So what that would be is you would take your existing NetLab infrastructure. We would just have a basic VM that they would get access to. But on the back end, that VM would be on this network. So it would just, it's no different than the system I built. He just already has NetLab deployed. So why wouldn't you use it? Absolutely. The idea is that you wouldn't have to stand up another public IP address and the whole 9 yards. He already has that stood up. So I would encourage you guys to kind of think of that over the next hour here while we wrap up some of this other stuff, kind of draw up what you would have in your lab scenario or some of the restrictions that you have. And the reason I need all that feedback is we can come up with different scenarios to match every single one of those. There may be ones that we can't do anything for because it is 100% sandboxed, in which case you wouldn't be able to serve virtual students, but we could at least serve the on-campus students. I also don't want to build a bunch of extras in there that aren't of use of people for this fall, because I think my plan here is to try to get this out before the fall semester. I'm going to work on it pretty heavily with all this other software dev that I'm doing, but I need it for my fall semester. So I apologize, Chi. You're probably going to see all sorts of GitHub activity. And that way we can have something launched and we can beta test it this fall. I fully intend to do that for myself in this class. Okay. Yeah, great. That would definitely help it. So let's make sure that our little Docker container here got set up. Looks like we're good there. So now we're going to run that triage. And again, this was just another way for us to utilize AI to interact with what's going on. So in this case, what's happening is we have a bunch of bundled alerts coming out of a system in a data set. Again, we're mimicking this, but these are the alerts that would be coming out, for example, out of Waza or any of these other monitoring systems. With that, we got some detailed alerts. And so now AI is kind of going in, triaging the alerts that are coming in, setting up like orders of importance. Which ones do we need to solve first? That kind of thing. What kind of origination is coming in? What do we need to pay attention to? So these are kind of the context of everything that's coming out of our SIME, the correlations, what rules we're using for that. And then now it's using the power of the Quinn 2.5 model in order to take all of those things in our context and see what we can pull out of it. So in this case, it determined that this was a true positive with pretty high severity and a 95% confidence score. And in this case, it looks like multiple failed SSH attempts from that deploy user, and that we have a CVE vulnerability on that particular version of OpenSSH, and that we should do some patching in order to pick that up. The evidence of a potential pivot attack escalation is warranted, so we should initiate containment and remediation efforts based on our incident response plan. So you can see how quickly that even this is running, even at 4 tokens a second. It's not very good. But it can take the information out of the system. We feed it enough logs and context that it can help give us a direction to go look. Now, if we feed it a bigger...
You're showing how to generate traffic, but then you're showing how it's then picked up and analyzed as well, right? Is that what we're seeing here?
So what you're seeing is we have some logs, some artificial logs in this case, just being generated, and we're feeding that information as context into the AI model and asking it to do a triage on whether or not this is a real attack or not.
Oh, perfect. Okay, great. Yes.
And so in this case, it determined it was a true positive, gave us some remediation steps, and we should be doing whatever we have listed in our incident response plan. So what it's doing now is drafting that incident response plan and what we should be doing. In this case, based on this particular attack, it's asking that we do containment. We should immediately start blocking that IP address based off the tier 2 analyst and disabling SSH service temporarily till we have it resolved. The steps that we would take for eradication, recovery, who we should communicate this to, and evidence that we should be preserving in the background. If you've done any kind of SOC work, this is fantastic. So normally we would have these kind of run books already drafted. When you're first starting out a SOC, you don't usually have these, and so you build them over time. The key is that we build our policy, and the best part is you can feed that policy into this so that it now uses your policy to define what that run book and how you would go ahead and fix this particular incident that came in. So in this case, AI drafted that run book, that run book, and then a human will decide how to use it. We can decide whether we like this one or we need to defer it or approve it. In this case, let's go ahead and approve it. And now we have grounded context on this particular incident, and we fed it yet another alert. So that is, again, this is mimic data as to how it would work, but this is exactly the plan of building this in real life in that SOC environment that Chi built out. Does everybody kind of see that correlation and how that would work? Great. So yeah, what you're seeing here is that, yes, these are artificial logs and everything, but we are actually piping it to a real LLM, and we are seeing a real LLM response that comes back out of that on how to fix it. So this is, and again, this is modeled based off how we told it to. So if we go look at the system prompt and tell it how we would respond to this, this is the style that we asked it to respond in. And then, of course, we told it to go ahead and draft a run book, and it would go ahead and spit back out that run book as well.
Jason, did it hallucinate the confidence rating? I'm trying to
Uh,
figure out how it calculated a 95% confidence level.
So the best way to look at that is, let's go look at the data for this one. And let's look at the alert queue.
That was a good catch. So that's
Or
why
in
you
this case,
that's why you have validate behind everything, don't you?
yeah,
Well, so you would need like a validation prompt, right? And you would also need to have a rubric for like your confidence level determinations.
exactly. Yep. So let's go in here and see. In this case, the data from the alert queue doesn't give us anything that would be in there. Let's look in the data set. And we can see the severity. So we can at least see the products that would be affected. And now we're going to look at the actual Python code to see if it's just hard-coded in there or how it came to it. So to see that, we would go into the output there. Okay, this is checking whether or not it's valid input is also in there. So let's see. You were also looking at the prompts here, so let's look at that real quick. There again, we tell it, and essentially the prompt we're telling it is you are a SOC analyst, your organization profile, blah, blah, blah. You will receive one alert with evidence. Respond in exactly this format. Confidence, it's saying give us an integer to 0, 100. So it is the model that's determining that. And then gives them information to determine whether it's false positive or true positive. So this is, you could figure this being your system prompt when we first start our communication with the LLM. I assume the run book is going to be very similar. It is, gives you the structure of why it should matter, instructions on how you would format it. And then let's see how it actually does it. All right. So it's pulling that in. It's pretty easy to find out. Let's see how it's calculating that confidence score. Alert source evidence. There we go. So in terms of a confidence score, it's set a max and a min. Confidence raw coming out of here. Grab confidence, parse the verdict. So we'll let that keep going so we can figure out where it's getting that. Okay, so it does have some sets here in that a deterministic verdict human gate works well without the model. It kind of hard codes it at 50. So that at least tells us it's using a scale. Let's keep moving through. I would say this is essentially your math. So it's doing regex on the score that comes back. Yeah, I would say because of the given data that we're in here, it's essentially making it up and choosing that number between the two.
Okay, that's what I thought. That makes sense.
However, I'm curious why it chooses 95. That's interesting.
We spend a lot of time on decision aids, and
Yes.
criteria scoring for our LLM usage, and so I was wondering how that was happening here. There's no way to really know how it's choosing the number, and then it's pretty confident.
Yes, and so I've run into that confidence type thing so many times, especially when I was doing that whole grain ticket OCR with context kind of thing, kind of a hyper deal, and it was passed me back, 50% confident, 75% confident, and then it's like 98. I'm 98% confident. I'm like, I'm 98% confident you're wrong. So I don't put a huge amount of trust in those confidence scores. What I did in that system was if it scored 60% or higher, it was ready for review. If it was lower than that, then we actually threw it out and caused it to do a rescan as to what came through there, and use context in order to determine what that would be. Yeah, I would say given that it's saying 95% every time, Python's doing Python things and it's not actually calculating a score.
Thanks for walking through that.
Yeah. So it's got a couple of examples here. Obviously, there's 6 total coming in, but the idea is going to be the same when we feed it real data, that if we get the alerts out of whatever system that's coming out and we feed it enough information for it to try to correlate it with, that we have written it in such a way that it's always going to expose it in this particular style. That's what I thought, just simple HTTPX. It's interesting how it comes into that. So what we would have to do there again, if you were interacting with this in our own setup, which we're going to have. So if we look at our setup here, we're going to end up having a VM here, which I believe is this NLP01 when it comes up. That one will have Ollama running on it, and that Ollama will host up that particular model, but we have to have our product running in front of it, in which case we have coded in, like we did there with the Python side, how we would want our system prompt, how we would want to interact with this system, that kind of thing. So if we just fed that information into, say, Claude or ChatGPT, we don't really get to adjust those system prompts. We can tell it, hey, act like a SOC analyst. This is what it's going to be. But we can't tell it to, do any kind of sensitization or remediation or redaction of that information. We would have to build those tools in order to protect our setup. All right, so to close out today, come back in here to the triage and the agents. So I talked a little bit about CI/CD and how agents would help improve that. And the idea behind that is it would generate, validate, and repair any issues. That AI agent proposes any kind of rule change, automate the validators that is given to it. Where CI/CD comes in is that validator is part of our test suite and human review. So if we go to deploy a upgraded package of whatever software that we are writing, that we would use this validator as a means of doing testing in that realm. So when I have that CI/CD pipeline, it's not just a matter of me committing out to, say, Git, and then using Git in order to deploy that out to some VM so that it's publicly available. One thing that we always add in the middle is different verification tests. And that way we could catch something early before it's actually deployed out to production. So I'll run anything, like I mentioned, Playwright and a couple of those, where I tell it to write an end-to-end test to make sure that all the buttons that we click on all work, or the new things that we just added specifically just work if we know the known stuff is good and we didn't change that code. That's probably the hardest part of code writing. I don't know how many of you guys have written a whole lot of code, is building the testing in. That's something I was notoriously horrible at. I would get it in there and you'd want to get it in production, but you wouldn't write those lint tests or those end-to-end tests that you should be. And then, of course, if I committed bad code, I broke the production, had to troubleshoot and come back. That is probably the biggest perk of where Claude came in. And like I mentioned, that's the reason I chose Claude early on, is some guys that wrote in Python were super impressed at how it wrote those tests immediately in the code without even being prompted to do so. And that's the skill sets that were designed that way to make sure that they were always adding test code in there. It was hugely beneficial from day one. All my code was significantly cleaner because it's been tested and verified. And now during that CI/CD pipeline, I can run all the tests, push it to a staging environment, test it on staging. That way I don't rock production. If everything tests out great, run it back through the pipeline again to go on out to production. One of the big things, go ahead, Terry.
Oh, I was just going to say, I see that one of the questions at the end of the day was in the AI assisted CVE triage exercise, why does the lab use bundled CVE data set instead of querying? And the answer being like to keep it fully offline to prevent from hallucinating. Is that what was happening earlier? He was talking about the CVE, the scores being off and.
Yeah, the reason that we did that in this Docker container was just so that you guys wouldn't have to have a bunch of internet access going in and out. The difference is you would want that going out to pull the latest versions of CVEs and that kind of thing.
That's what I thought. Okay, but if we wanted to keep it fully offline, there's a way to handle that too as well, right?
You got it. In this case, it downloaded those CVE data and generated those files that we just looked at here a minute ago, these text files, and that's how it's pulling that. So the CVE data set, it essentially downloaded this, so it's ready to go offline. Now, it's only going to work for these particular CVEs that we pulled out. So you can pull these bigger logs and do offline stuff. That's pretty easy to do. And then if you need to do updates offline, you could transfer that file across and it would update the database. That's easy enough. One of the big pieces of today, as you guys have seen over time here, is the smaller models are great because they allow you to get some more performance out of low-end hardware. The real problem is you're at a bare minimum, in this case, need the 3B model because it actually has tool calling. And with that tool calling, if you have less than that, you tend to get malformed JSON requests coming out of there. And a concrete example of that is matching the model capability to the task. So newer models are more inept at doing tool calling. And you'll notice that if we go out there to Ollama and look at these tools, you specifically would want one that has the tools tag on it. And that would allow you to know that it is set up and ready for tool calling, ready, and it's set up. If you don't have one and you use one that doesn't have this, it can be tweaked to use it, but it doesn't do it efficiently. And so you want to try to pick one of these models that has that in strong for efficiency reasons. Even though things like DeepSeek can do it, it is also a thinking model, and therefore it's going to chew up more resources when it goes through. Yeah, Johnny?
Do we know which one of these, each model, what tools they're able to run, or that they've been pre-trained on?
No, in this case, all it is saying that it has the capability of running tools. You add those in through either MCP packages or CLI tools.
All right. So basically, it's just trained on the concept of running tools.
It has the ability to do outside calls to run those tools. That's the main thing. Yep. Yeah, there's no actual tools built into these individual models. You supply the tools separately. And so again, when we did a lot of this, usually that Quinn 3 works really well. I wouldn't use the coder version for that. This 3.5, and then we did the smaller model, was capable of doing that. You would have to find the breaking point in there. The other problem with some of these is the smaller you go, and obviously if your system can't handle it, the context window is too low. And as you can see, even there in Claude, see if it'll actually pull it up on this one now that I've been doing things. It's in the process of testing out that scenario. But if you were to
Why are you going into that? My question also is, if we're going to plan on using something like this in the NetLab, what model would be the preface for, let's say, a NetLab environment, the standard, let's say, renewables?
You would probably want to use that same Quinn 253 that we've been playing with all along. If you're going to be running pure CPU and RAM based, if you have the ability to give it a GPU at all, you're going to get way better performance out of it. Is your underlying hardware the Lenovo's?
Yeah, for right now, that's what we have. When we start looking at newer servers to implement in, that's where we're going to start venturing in some TPUs and possibly some GPUs if we get a hold of them.
Yeah, so if you stuck in that platform that we've talked about there, let's see, you would go, and are you guys typically AMD or Intel?
Right now, everything is Intel. We're willing to move to AMD since it operates better. It's underneath Proxmox because we were Intel to begin with. That's what it was for. If we could shift to AMD since it functions a lot better underneath Proxmox, we can do that.
Yeah, and I wouldn't say it's necessarily like 100% better kind of thing. Now, with those little boxes I'm using, that's different. They're essentially desktop processors, and therefore they do run better in Proxmox as an AMD side. On the Intel side, you usually don't have on these servers the concept of the P cores and E cores at some of those, but we've gone both ways. I mean, it used to be Intel just smoked everything, right? And I mean, even way back in the day, AMD kind of caught up. It's taken a long time for AMD to catch up. However, if you look at a lot of big deployments of using NVIDIA graphics cards with AMD processors, these epics are like the cat's meow when you go to that. So you would go to like an epic style processor with a graphics card that could handle the load of what you're trying to feed it. The best AI workstation that I was going to build out was really based off a Threadripper AMD, along with those RTX 6000 Pro cards. That would give you some pretty mean performance in there. But even that total cost, you're talking at almost 10, 12 grand just for the system with the processor. And then you throw the RTX 6000 on it, which is now outrageous and up to 12 grand. You can wrap up some money really quick in those. I do believe it was the 665, I think, was the basic setup for the AMD side. Then when you jump from the 665, I think you have to go clear up to the 675 was the next model that we were looking at using or recommending for people, unless you went really big on the Intel side. So there again, it depends on what model you got and how many graphics cards you want to stick. This one allow you to do up to 3 GPUs of the double wide side. I believe this one lets you get up to the SMX or the SXM platform. Cost was going to be significantly higher. So that didn't send me there. Were they out of stock? Yeah, it looks like they don't even have those in stock at this point. Just keeps redirecting you off. That 650 model, or 45, it should be for Intel. 665, there we go. I'm curious what they're currently offering with all those shortages and everything they had out there. So I would have to go back and find the right AMD EPYC processor that I was chasing at that time. But what I'm really curious is what graphics cards they're allowing here. So this is the L4. It does look like they're offering the 6000 Pros in there. Obviously, they want a huge penny for them. Now, that one in particular is the Max Q. You wouldn't want the Max Q unless it can't handle the power being the issue. That's one of the reasons it has an issue there. That 4500 would be another start, but you're bottlenecked at 32 gig. So there again, this is kind of one of those entry systems that it'll get you there. It'll get you started. By the time you add all the stuff in, you're usually in that 30, 40 grand by the time you get all the pieces in there, not including RAM. I don't even know what RAM is at this point. Where are they at on sticks? They are, my goodness, supposedly 5,000 a stick, which seems awfully high. Now it is Lenovo.
Will those servers be able to take our old sticks from our old Lenovo's?
No, you won't want those because the problem is those don't have the bandwidth.
Okay.
So your old servers are usually, I'm guessing, DDR4, and there's a massive jump between DDR4 and DDR5 when it comes to AI.
So how if I come up with one of those systems there, let's say 34,000 for one,
Yeah.
what's the amount of students I can support out of one box?
It depends on there again what model you end up loading into it. So if you load up that Quinn 2.5 and you want to have 10, 15 instances of it so that at any point in time 10 or 15 students can be hitting it hard, then you would just multiply out the RAM usage by whatever you have for that graphics card with a little bit of overhead because you still need context on top of that.
Okay.
I wouldn't expect that you would be able to serve more than, depending on the card that you put in there, 10, 15 requests simultaneously, something like that. If you want something significantly higher, then you would have to step up to the higher model where you can use like the H100s, and now you're talking $100,000 server to start. It's very, very expensive to do it on site. Very expensive. And that's kind of the flip-flop that I've always done. So I always wanted that RTX 6000 Pro. Even at $7,000, it was really hard to justify that. Now at $12,000, there's no way to justify it unless I absolutely had to have something on site. A customer didn't want anything to come off, couldn't use a third-party API, that kind of thing. Otherwise, you can buy a lot of API usage for $100,000. And it will not expire in terms of hardware. So, if hardware changes and leapfrogs yet again, which it does very, very quickly in AI realm, you just spend $100,000 on a server that's no longer going to serve the next models because the next models chase the bigger servers that are out at that point in time. So there's a pretty massive trade-off in there. And if you're using a one-time grant to do it, you're pretty much locked into that hardware for the life of that grant.
Yeah, some of the downfalls of the grants, though, you can't do services, but you can do equipment. So there's a finite rule in some of those grants.
Yeah, I run into that all the time with the schools that have done that. And so the real question there is, like you said, you can buy hardware, be local. What I was always looking at there was being able to take some of those grants and pool together with other schools so that you could build this, so NDG had this real big concept of academic cloud. And that took some of the bigger schools that had the bigger grants, stationed those a little bit strategically throughout the US. And then anybody that joined that cloud would have access to that hardware and that. And my understanding is you can use hardware for that.
What about channeling a bunch of Mac Pros? I've seen a lot of people do something of that.
Yeah, so
Mac Pros as being the back end.
Mac Pros is another option. And yes, you can cluster those together. The problem is you're back to that system unified memory. So it will handle it in terms of much bigger RAM. You can load those particular models, but the throughput and performance is significantly lower because you're now using system RAM as opposed to GPU style RAM. It comes back to a bandwidth thing. So you can actually load a 7DB model where I can't even do that on a laptop, right? But your throughput's a little bit less. What I've seen and what we've tested in that side, so we are in the process of waiting. I believe NDG was working to try to get a couple of those MacBook Pros to test them. They were out of stock and outrageously expensive, so they tested with those GB10s. And I believe, I don't remember which models they went with, whether it was the Dells or another brand or something. They're all the same hardware at that point. It's just who put their name on them. They're all in this similar price range and setup. These worked. They do run those locally, and you can tie two of these together. There's a backplane for that. You can see that here. You got your QSFP backplane. Once you get beyond
How many students can you support out of one of those?
What's that?
How many students can you support out of one of those?
That's actually
If
what
you
we're
start
chasing
using
right
this.
now. I don't have a solid answer on that, but we are chasing that at NDG. Because this might be the best solution in order to make it work, but you won't get
Yeah.
the highest performance out of it.
But then you're looking at a price cut there. I can get, 10 of those, 20 of those for the price of one server.
You can, but if the performance is so slow that you can't actually utilize it, then that doesn't do you any good. Does that make sense?
Yeah, it makes lots of sense.
That's actually what we've been chasing is yes, the L40S cards or your H100 cards, all of that is outrageously expensive, but it gives you finally that performance that you can utilize something local without the student just giving up on the lab. These, from what we've tested, is it will work. It's just how many students can we support through it that is a cost per student kind of load. If we can get this to support maybe 2 or 3 pods, 4 pods, great. I think we could do that, but now you're talking a cost effective of $3 to $4 grand per student in a simultaneous fashion.
Right.
The other part of that is everybody working on your system asynchronous, or are they all synchronous, aka walking into class and trying to hit it all at once? This is definitely one of those that leans to that asynchronous fashion. In other words, students do the labs when they have time to do the labs. You're going to serve a whole lot more students than you ever would with walking into a classroom, everybody jump on one and go.
Right. I mean, that's what we're doing at our institution is our classrooms, we're trying to upgrade to the decent level to where we can just throw another, like you're saying, maybe go buy a bunch of 20, 40, 80s, 40, 90s, even the 5000 series of the RTXs, stick them in the boxes and do some classroom level stuff. But anybody that needs to hit these labs from remotely would use that equipment there. That situation.
Yeah, I would say the minimum that you can do to get some decent testing out where the performance is fairly good would basically be the equivalent of what I have in those other laptops. So those are the laptop version of the 4090.
Something like that.
It's the 4090, and I think they have 16 gig of RAM. I believe that's what those were. They were a custom built P16 is what they were. Yeah, that was the one that I pulled in on that side. About 16 gig of VRAM. Normal desktop version has 24 gig of VRAM. That's why I wanted to make sure I wasn't getting my numbers confused. So that 16 gig of VRAM with that level of processing, that one we can do a lot of classroom style work, early editing, trying out different models, actually get some pretty good performance out of it. I can still do video generation. I can do audio generation, image generation. Something in this mark works really well. So obviously, if you grab the desktop version of this, you can do just fine. I don't know that it's worth the jump to the 50 series at this point, just because of cost. We do have some 5090s and some other systems that just got ordered right before school ended, so we'll know more this fall.
What I've been looking at is a lot of the 5080 or the 5080s that are coming out right now are testing even higher than the 5090s for some reason. It's really strange.
Interesting.
Because we got a few of those Lenovo Legends i7 Pros that have the 5080s in them, and we had one that had a 5090 in it. And
okay.
The difference, it's not hugely significant, but when you look at a price range between the 80s and 90s, you're actually getting a decent function out of the 80s now. So that's kind of what we're looking. That was the other approach, like what you're doing. We have desktops, but the laptops we're looking at maybe upgrading to would be the Legion's, the i7 Pros, which come with the 5080s.
Yeah, and then
32 gig of RAM.
End of the day, it's generally how much VRAM it has. So, the big difference on this, whether it's a 4080, 4090, is typically the amount of VRAM, but you also get a burst in bandwidth and more shaders and things like that under the hood. But it's really that sheer amount of VRAM is what you need the most of. And like I said, with 16, a 16 is kind of a bare minimum. If you have 24, it gives you a little bit of room to have more context. And you can play with a lot of models on Ollama with that size card.
I hate to pull it off into a tangent. I was just trying to look at equipment waste when we're looking at doing this.
No. This is the this is the part of a workshop I like is getting feedback from people and what they're trying to do and everybody sharing their stories. Because this, I have this particular unit. When we first bought those laptops, it was, I think we spent about 105 grand, but we had state money for that particular purpose. And the vision behind it was I wanted those laptops, and this was 4 years ago, so before this stuff was hot and heavy. I wanted to be able to load it up with a model, send students out to do cybersecurity audits and pen testing for small businesses, but it would keep everything local at that point. We would already have a particular model we trained to help the student and give them feedback as to what they should be doing. And then at the end, we could just clear it. So everything stayed local, right to the laptop. They checked one out, went on site. We wiped it when it got back. But just now is about the time we can actually implement that, because up until then, there was no models that really pushed that. Up until, I would say, about a year and a half ago is when we finally started testing that.
Yes, that's what we want to do here. That's what we want to implement, something sort of that. So we're looking at some of the grants that are available. There's a few cyber AI grants that are out there now in the workforce areas. That's kind of what we're trying to envision. I'd love to pick your brain maybe offline to see how you're approaching that, so we can actually kind of do something without having to reinvent the wheel.
Sure.
It sounds like you're going in the same direction we are, and maybe we can work together on something that can work in our area.
Yeah, no, I'm like I've said before, I'm definitely an open book and willing to help people out in that realm. I'm not pushing as hard here at Fort Hays because I won't be here for as long, but I definitely like helping other instructors with all the stuff I played with. I've been fortunate enough to play with enough hardware to figure out what works and what doesn't work. And like questions like Chris has, what's a general rule on GPU RAM to system RAM? You generally want a 2-to-1. So if you have, 16 gig of video RAM, you should have a minimum of 32. Now, obviously, you got to run the operating system and all that under the deal. So I don't like systems anymore that are less than 64 gig of RAM, especially if you're doing AI stuff. If you can push it higher, great, but there is a limit. So that was one thing I figured out with those P16s that we ordered. We ordered them with 128 gig of system RAM. And I was like, this is great. We can load up all the VMs we want. We can do all that. Yeah, no problem, Beverly. But the problem that we found is by loading it up with 128 gig of system RAM, it brought down the bandwidth. So it had to knock down all the clocks, and it didn't just knock it down a little bit. We bought the best sticks we could for 128 gig. I think they were 6,400 or whatever. It brought it clear down to like 2,400 on the bus because of the way that system board was designed. So we actually lost all that speed of the RAM itself, which means when we offload that in the AI side, well, now that RAM is slow to a several orders of magnitude than if we would have just put 64 gig in it. So I think there is a happy medium there. It just depends on the motherboard, what the system can handle. The laptops are great because they're portable, but if you guys are trying to do anything serious, desktops are definitely the way to go. And a lot of that is thermal throttling. So that's one thing we ran into when we were doing some heavy models, is those laptops would thermal throttle pretty quickly. Even if we turned it all off, and we made some tweaks to make some of that stuff bypass everything and just let it run as hard and fast as it could. It still will thermal throttle. They're mobile GPUs. They're going to be capped at some point. So I think
that's kind of what we looked at the Lenovo Legions with that huge thermal back end. They had really good heat dispensing unit in
laptop.
there.
Was that the desktop or the laptops?
Laptops.
Yeah. So the P16 that we went with, the only reason I went with the P16 over the Lenovo Legion at the time when we ordered those was we could get more system RAM in the P16 that allowed us to get to 128 at that time, and we could steal the 4090 that they were putting in the Legion to put in that laptop. Normally, your P16 line is the workstation level stuff. Right. Which actually for AI would have been better. So had we ran I think it was RTX 5000s or something like that was the equivalent of the 4090 at the time. It would have done better on the AI side of things, but we were also using these for other purposes that particular card would not have been great for. So whether the students were doing a little bit of gaming or something like that for testing on the side, or if we were testing the different drivers. Because that's one thing too, is if you load up a 4090 card with the drivers and then you load up a workstation level card with the workstation drivers, you will get more performance out of the workstation card. That's just how it works, because the drivers are tweaked more for those AI loads than they are on the consumer based level cards. Doesn't mean it doesn't work. It's just that last little bit that you're trying to get out of it. The workstation cards will perform that better. The other part that we went with the workstation cards was we were loaning these out to do shading on like Unity projects. I mentioned yesterday that we were doing like a VR project so that you could work through a data center, etc. We were loaning these out to help build a server farm so that they could do that shading over the weekend really, really fast. That was kind of when we went down that route.
Because I know that Lenovo's pushing out some of their newer laptops that are AI-based ones. Those things are running like $8,000-$9,000 a piece.
Yeah, and a lot of those are like the AI Strix and the 3095 procs, and those are more system unified memory type thing that we were talking about earlier. And again, all that does is let you run a bigger model, but they're still going to be slow because they don't have the horsepower to do it. So, and by horsepower, I'm referring to bandwidth.
Okay.
But no, I'm happy to chase these. If the best way that you could do is a desktop and you can put a 4090 in it, if I were you and wanting to do AI, instead of chasing the 40 series, 50 series, I would try to jump to that like RTX 4000 Pro, 5000 Pro, 4500 Pro, and get that VRAM of the equivalent of that. And you're actually going to be the same, if not a little bit higher price, but much better output for AI usage. So let's see, I believe it's the RTX. Well, they got the 4500 Pro, and you want the Blackwell series. That's the one I'm referring to. Those still sit around that 3800 mark, and I believe, how much was that one? 32 gigs. So this would be the equivalent of your 5090 graphics card, holding the same amount of VRAM, all that kind of stuff, but you will get more bandwidth out of this card for about the same price as those 5090 cards. And if you were to step that up from that one to the 5000, looks like they're about 1,000 more roughly. And these are obviously guesstimates as you're pulling through. Whoop, that one pulled to 4,500. There's the
Now, are
5.
those full desktop size, or can they fit into some mini desktops?
No,
It's
you wouldn't be able to
small,
handle. Yeah, the mini desktops wouldn't be able to handle it. These are full desktop cards. Even if you had a mini PC that would hold a full desktop card, these are typically double to triple depending on the particular card. But the thermal throttling and the power requirements, those mini PCs would never be able to support that. Now they make a version that would, and that's called the Max Q versions. Those are they don't show out as much power as the full versions of them, and you can get away with that because you may not need that much power to drive them. What the Max Q versions are for is if you want to run multiple cards in one system. That keeps you below the thermal throttle limits and the power limits of most GPU or power supplies, and the bus, the PCI bus. This one here was actually one that I chased down forever, and then it was the regular 16,000 or the 6,000 Pro. But now all everybody's selling is these, and they're outrageously expensive. And I say outrageous because the day I was going to buy them, it was actually closer to this price. And I was trying to find the funding source for that, and I couldn't get them ordered. Next thing I know, they almost doubled. So a good way of demoing that, and I probably had this multiple times here, but I can find it again. Sorry, I was typing this in an off screen. So this is how I kind of interact with Claude to help me with these kind of things. And it works really, really well. So I come in and I say, look, I want to know about the RTX 6000 Pro. Compare that out to the GB10 and loads in terms of loading models for inference. I want tables and I want interactive HTML file to help me show those key differences. That phrase or that prompt engineering is typically how I will go and compare two products. Sometimes I'll feed it 3 or 4 products to kind of get up what that would look like. But this has done this multiple times for me, and it builds a really nice website that demos why this would be in there. Let me see. I'm curious. I've got this, but it's been a long time since I built it. Give me a second here. While that's running, I'll pull this demo of what we had pictured for NetLab and how that would work with these type of units. So that's another problem in NetLab side. And that's why I was trying to explain how this would work. So I was really hoping I had those files here. I'm sure I do. If you were to drop this in on a Proxmox setup and then you divvied the graphics card out, whether you wanted to map that to one VM that students would have access to. Yeah, I'm sorry. Chris is actually probably asking the same thing I'm about to cover. I apologize. I didn't see your text message come in there. If you build it in a centralized server architecture with, say, Proxmox, you would either need to A, pass that through to a VM, or B, you would chop that big, say, RTX 6000 into multiple small graphics cards, maybe something with 16 gig. And so you would chop your 96 gig into 16 gig chunks. That requires a very specific NVIDIA license to be able to do that. And it's extremely expensive in order for you to do that. As a matter of fact, it'll end up costing you more in licensing. Even with the academic side, will cost you more in licensing than it almost did for the card itself. Sometimes you can get some perpetual licensing there and some other stuff. So to get around that, because of the way they do their licensing, is you would load those all up in one particular centralized server, and you would proxy the access to those systems from a third party. So that would be like the OLA server that we talked about, or throwing up light LLM in front of it. And you would have those individual pods connect to that system for pure inference. So the reason NVIDIA licenses that is you're basically given a GPU access directly, not necessarily AI inference, right? It could be for anything. You could be beefing up the graphical performance of those inner VMs because they have access to that GPU. So their licensing is very much tailored around that. If you go the other route where you start serving it up as kind of another alternative, then not only does it go around the licensing in a legal way from everything I've seen so far, you would actually get ultimately better performance out of it, because now you're not chopping it into 16 gig chunks, which is the whole problem anyway. Otherwise, you could just buy a bunch of 16 gig cards. It gives that full power of that 96 gig of VRAM to it. Therefore, you could load up a couple smaller instances, a couple smaller models, and then one really big model for making it available in inference. Or you could load up a big model with really big context in KVM so that you could serve up multiple threads going out. So you can see how it built this little HTML thing. Usually I ask it for interactive for a reason. I forgot I did put interactive. But the nice part about that is it usually gives you sliders, so you can see costs and comparisons there. These would hold roughly the same model. So if I gave it, 128 gig of RAM over here, and I've got 96 gig of RAM over here, from a RAM perspective, I can hold the same models in between the two. The difference is that bandwidth. So when you look at a memory bandwidth of a GB10, you're significantly to the order of 8 times less in terms of bandwidth, which is going to give you the ceiling of how many tokens you can stream at once. So even though there's more RAM here, it isn't all about RAM. It's really dependent on that bandwidth inside of there. When you're doing F4 compute, you can see here you're 4 times the amount. Yes, the cost is less, but it's not 4 times less, right? You're half the cost, if not maybe a little bit more, for that extra kick here. Now, the difference is, and you do need to figure this in, is this is a full complete system. This is just a card. So the card that would be, or the system required to really drive this one, you're still going to spend about $8,000 on that system to have enough CPU threads and some other stuff in there. If you're never going to do any kind of training, which is very CPU thread bound, then you can get away with a smaller proc. You don't need the real high end Threadripper. You can get away with a smaller one for this, which is what I was looking at when I got away from training in general. I realized it was significantly cheaper for me just to do my training on the line and pay for that API cost than it ever was to own that big CPU that would be required to do training. So this one does a good kind of comparison here, and it did get you some interactive. So a good example is this Llama 70B. That's kind of a gold standard that I've used a lot. If you stick in a full, in this case, 4-bit or like an F16, we haven't really talked too much about the precision levels, and we can dive into that a little bit more. F16 is kind of the raw parameter format, and therefore these will need way more RAM, as you can see here. It needs 140 gig just to be able to do anything. And by the time you add your KV overhead, which is essentially your context and such, you're going to need 170 gig of video RAM in order to hold that model. So what they have is the ability to lower the precision down to an F8. And then from F8, they go to 4-bit. And then from 4-bit, they get into quantization. You never really want to get past, quantization of 4. I think 8 is kind of the breaking point. That at that point, you really chop down the model. So the closer you can run it to full F16, the better off you are. But in this case, you can see I could run this 170 gig model and it would just fit even with my context overhead in both systems. But you're going to get 3 tokens per second out of a GB10, and you're going to get 22 tokens per second out of a 6000. And then when you start looking down here at memory bus, the difference between the two, where that memory lies, and exactly how many CUDA cores. So even again here, you're capped at about 6100, and you have almost 4 times the power out of this other individual card. Does that help in terms of kind of demonstrating the specs? And like I said, I built this so many times because I keep forgetting the exact spec numbers. I used to have all these memorized, but I can't keep up with anything anymore. Great. So there again, it's hard for me to put down the GB10 because it is a self-contained, put it on a desk, go do your prototyping, go do some cool stuff to learn from. It absolutely handles that. But if you start throwing at these bigger models, you just have to expect that 3 token, which is roughly what some of you guys were able to find here. Now, if you bring that back down to a nice 7B model, which Llama 8B is, and these are some older models, but the idea is you can get quite a bit out of these. So, even on this 70B at a full F8 precision level, you can fit multiple of these in and you can have a really high tokens per second. Even on the GB10, it has no problem. It can handle it really, really well. So you can load up 2 or 3 of these models, and then you can have 2 or 3 people hitting it, and you would be much better off. Now, to really get to the numbers of how many you can host per student, your best way of doing that is using VLLM versus Ollama. So if you use raw Ollama, it's not really best on threading on how that works. And therefore, I think you can only get up to 1 or 2 streams by default in the config. VLLM can serve a lot more. It does require these higher precision models in order to do that, but you do get some better threading with multiple users using it. So that would be a great way for it to demo here instead of me visually talking about it. So for those that can't see the screen or what I did, I basically went back and said, look, I want to serve 20 students accessing those two systems. How many students can I have simultaneously? That gets us our parallelization. And then really show the difference between hosting with Ollama versus VLLM for increasing that performance, and the different precision level adjustments, which is that FP16 versus 8 versus 4, and then quantization, where you can get the different numbers in there too. And what I found in this is this gives you kind of a benchmark of what you can do to test. You really have to go out and play with it yourself. And the more you're willing to spend tweaking the VLLM config, which again, now that we have things like Claude Code, is dramatically easier to use, because it will sit there and iterate. It'll try the new config, run through a series of tests, do it again, do it again, do it again. That is what we were doing manually over the first part of last Christmas break. We wired, I think, 6. It took 6 of the P16s with those 4090 graphics cards to do the Llama 70B model. And we were able to load it up in the full VRAM. We had to put a shared storage between all 6 of those laptops. Again, we could only interconnect them at that point. Yes, we did have 2.5 gig between those. And it wasn't enough. I think that still pushed it down to about, I want to say it was 6 to 8 tokens per second. And that took 3 weeks of him trying to do different VLLM configurations. Unfortunately, in January, after I started playing with Claude Code, I could rebuild that entire thing and all his configuration changes. And we could do a lot more testing, and found out that was about the tweaked max. You will find when you do these kind of things that whatever you're using to serve it, so whether it's VLLM, Ollama, LM Studio, OpenAI type packages, that part matters. It also matters the drivers that you're using under the hood in order to support those. So your versions of PyTorch and your versions of all this other stuff to make VLLM work also dictates what versions of the NVIDIA drivers you have to use. So whether you're using the latest and greatest, do you need to go back 2 versions in order to make that work better or be more stable? All those different iterations we had to go through and test in order to make that work. Which is why if you look at that P16 software that I built there for deploying these kind of things, all those different parameters are adjustable. And we built a database in that installer that knew that if we wanted to run this model, it knew it had to run this driver on this setup with this version of Python, et cetera, et cetera. And it would deploy the whole system. And if we wanted to change the model, we would have to change all that back out. So I apologize. That was a massive brain dump on everybody, but those were really great questions. I appreciate that. So let's see. You were talking this 90XT. That's a AMD card. Is that right, John?
It's an AMD card. The higher end versions of it, about $600 or $700 a piece for 16 gigs of VRAM.
Okay.
But the memory bandwidth is over 500 gigs a second. Pretty good, low power. They only take one connector, one power connector. So if you have a dual GPU motherboard, it's pretty good. 32 gigs of VRAM. That's pretty fast and really good paired for local AI with a cloud model too. So if you have like a cloud orchestrator and then local AI for task execution.
Perfect. Yeah, I believe that is the model. As a matter of fact, as I pulled that up here, that is the model that we started putting in those MSO2s. Because they fit really well, not in the MSO1s, but that O2, I think it's MSO2 Ultra. Almost positive that, yes, it is. We started pairing that in the system, and I got a guy testing that right now as part of the MSP that I work with. We were using these systems because we got these back before the tariffs hit, and so we were getting them fairly cheap. But that, if I recall, yes, it had those 2 slots at the top that we could use for that.
I haven't been able to test them head-to-head with the new Intel Arc Pros, though. They have similar memory bandwidth, and Intel has 32 gigs of VRAM for about $1,000.
Oh, nice.
So be a little bit more cost effective, but they're not as mature as Rockham with their framework.
Yeah, and I've had fairly decent luck with Rockham, at least, like I said, with this onboard one that I have in this laptop. That's kind of why I went this route. Obviously, I didn't buy it for the AI side of things, because at that point, what I decided was I needed a rock solid laptop that had really good had good system memory, but also had massive battery life. That was a huge jump going to AMD and Linux. Battery life was way better than my other P16s. What I was really hoping and holding out for is the new models of the P16s can not only do AMD, but you can get discrete graphics cards in them too, which is literally the RTX 4000 Pros or something like that baked right into the laptop. Now you're spending $8,000 on a laptop though, so.
Don't leave it at Starbucks.
Yeah, definitely not doing it. So here we go. This is what I wanted, was this little interactive tool. And so depending on what size you want to go with, so say we go with that 7B, we're going to need a context window of at least 16. And I say at least 16 because, as you guys have seen, depending on what you're all loading up in there, and you're going to actually do some tool calling without clearing context constantly, you're going to need at least 16. Usually I like to get to 32 if I can possibly do it. And again, if we use F16, we can't do that. Don't have enough VRAM. And there you go. So if we do it with Ollama, this is about the numbers I thought it would be. Even on an RTX 6000 Pro, you're only going to get 4 students. And the reason is you're capped on the number of parallel when you use that model. If you tweak it and get it set up right with VLLM, you can serve up to 47 students out of there at those parameters that we set. So it's a massive difference between the two that are serving the exact same model. The difference is you have to have those little bit better precisions in order to do that. If you can go down in precision or even quantization on this side, you can start serving more and more students out of that. Now that is a 7B AB model. We tweak it up here to a 14B. That didn't drop as much as I thought it would be. Obviously running a 7B model, we can still serve 9 students out of there. So that was kind of what I was hoping for, is if you had 1 to 2 of these, we could serve about 10 students each one. And that's still maintaining a 20 tokens per second. But we're definitely struggling on the quantization as you go through there. And there again, if you bounce back up to F8, now you're back to 1 is all you're end up going to be able to serve out there. That was a good chart it came up with there. What I was looking for is it would show us the quantization side. There we go. And let's see. Yep. So if you stick at that M4 bit, that's going to give you the highest precision. As you go all the way down, you're going to get the Blackwell support. I was hoping it would actually explain the differences, because when you get into these models, this is probably the part that took the longest to decipher. Yeah, so you'll start seeing numbers like these out here. So you'll have either your core ones up here, or you'll have the MLX ones, which are the mix. You'll also have your, notice that matches those NFP numbers that we were talking about. You'll have your Bs, and then you'll hit your Q4s, KMs. And that is just meant that it's been quantized pretty heavily. You get to Q8s, it's even more quantized. Or I'm sorry, less quantized. That number gets higher. That's the other direction. But that shrinks the model size. So you can see that it goes from a 30 gig on a Q8 to a Q4 of 18 gig, which means you can kind of fit that in, VRAM. This isn't an exact number that you would need in VRAM. It doesn't necessarily correlate 1-to-1, because by the time you get this number in there, you also have to have room for this context. And that context will chew up more of that video RAM. So Claude is really good at, or any of the tools. There's several tools out here that'll kind of help you plan what it looks like in order to host those particular models. Let's see if I can pull that back up there. As it said in a rule of thumb, if you're going FP16, 4-bit ends up quadrupling the number of students you can hold and double the amount of throughput, often turning SERPs 5 into SERPs 20. So just a little bit of quantization inside of there, and you can do quite a bit more coming out. Crank that up. Bring that back down. We can do quite a bit inside there. Now, again, that's a really heavy model. So bringing it down to a 4-bit, we can at least hold a little bit more in there. Does this kind of help everybody understand a little bit on how throughput serves things up? I have no problem, by the way, downloading this. And I think I can do this. Possibly in chat that came through for everybody. So you can actually download that HTML file and be able to play with the sliders and move some stuff around there. It is about as clear as mud, Chris, and I get that. It's taken me 6 months of studying these kind of things to truly understand them, and I can't say that every time I haven't even seen these particular MV4P stuff, this 4-bit stuff. I've never seen that. The Q4, the Q8s, those were the models. We knew if I could get to FP16, that would be fantastic, but it just took up so much RAM in order to get that. These are your cleanest of the clean models. So when you run training, you want that FP16 precision. As that starts to go down and you cross over that threshold, then all of a sudden the system just doesn't respond very well. You start getting hallucinations, bad information. You've essentially chopped up the amount of memory that it's holding inside of it. What's cool, or the ways that they've started to get around this, is start to go with those mixture of experts and some of these other models. And so what some of the new models will do is they are call it, 35B or 105B or even 235B models, but they only load about 3B into memory at any point in time. So it will actually clean it up and only load up 3B into actual memory. I don't know that this is one of those models, but that was one of the new bragging points of those, that while they're a significantly larger model, they only have to load much. So this is a good example of one where it's 120B open mixture of expert model, but it only activates 12 billion parameters at a time. Therefore, you can fit it on smaller cards. Yeah, and I'm fully familiar with cyclical funding, especially if you can get the grant money and how that runs. That's the worst thing about grants. You get all these cool tools and everything works, and it will last as long as the grant does. Once the grant dries up, obviously nobody wants to fund it or keep it going at that point. So once the hardware dies, it dies. I was fortunate enough to have $500,000 budget when I took over the Cybersecurity Institute. And even with a $500,000 budget, I was way too frugal because they took all the money back. And it wasn't that I wasn't spending it. It was just trying to do the exact same thing you guys are doing. What's the best bang for the buck? What's actually going to make an impact on jobs with small businesses, et cetera? Because that was the basis of the grant. Or in this case, it was a Kansas line item budget. And it was reoccurring. So I got $500,000 every year that was coming through there. But that was to serve and pay students to go service small businesses, all those kind of pieces. So it is overwhelming looking at all the hardware. I get you. For those of you that use the NetLab systems and look at the NetLab server specs, I've literally built those server specs since 2006, 8, somewhere in there. I'm usually the one that goes back and builds those out. And we always build them out with schools in mind, right? Literally working and operating at a school, knowing what the school process is for procurement, making sure that we're picking the right CPUs. You don't want to throw the biggest ones in there because you're not going to get the bang of the buck for it. A lot of times, and that's the reason you saw this, especially a couple of years ago before this whole RAM shortage craziness, is we would have kind of relaxed specs on some of those, and we would encourage people to buy more than one server. Instead of building one big server, we actually wanted you to buy multiple of the individual like high performance or mid performance tier. And the reason is you actually got some redundancy out of that, and it would help share the load in a NetLab style environment versus some of these guys just wanted to go spend 100 grand on a server. And it's like, you're putting all your eggs in one basket. And if the power supply blows or something in there, the whole system goes down. Proxmox is even better at that. VMware was even more sketchy on that, but Proxmox, it runs much better that way. You know, if you lost your management server back in the day, then your whole system went down because you didn't have vCenter anymore. At least now you can kind of pick up the load with the way Proxmox operates. Yeah, no problem, Chris. Not a problem. I chuckle because back when we did the Dell 710, 720, 730s, I could list off every part number, serial number, absolute spec. I don't know why my brain always worked that way, but that was the memorization I used to do back in that day. I have now found 40 plus and realized I can't hold that information like I did when I was in my 20s and 30s. And for those of you with those server specs or looking at NetLab systems or have NetLab-based questions, that kind of stuff, let me know, because I've worked with a lot of schools on optimization. So the best bang, what can we do to these systems to make them last longer, that kind of thing. NVMe was the biggest deal. So 710, 720s, adding in just NVMe PCIe drives gave those things entirely brand new life. Once you got off those spindle drives, you could service so many more students. The IOPS just dramatically changed overnight. Those were huge improvements in that realm. So if you're building new servers or specs, sticking with NVMe, the new ones are all going to be U2, U3 drives, that kind of thing. There again, before everything went nuts, we found some really great pricing at Server Supply. And I was doing those online workshops for NDG on helping people get their servers upgraded. And everybody that went to the workshop must have bought them because they immediately sold out. And then when they came back, all the tariff stuff hit and everything tripled, quadrupled in cost. Yeah, sounds good, Daryl. So to check in with where we're at on the rest of the day here, I believe we've covered all the topics I had specifically out there, other than AI enabled, this side here. So that comes back where we were talking about being able to host those 3B models. And I think we went off on that long tangent. So hopefully that was good information. But it is significantly harder. And if you get smaller, you're not able to do tool calling very well. So you want to stick above 3B, and there's some trade-offs in that, whether you need that cost savings, whether you need the privacy for the local, but it's really down to capability, compliance, and performance. You can do it. It's just not going to be as performant as you would like. That was a good answer there by, who said that? Let me scroll back. So I want to give credit there. John there, in terms of like that AMD one, those are a great way to go. So if you can do a mix of doing online stuff, which is really what I've done here at the software company, is use my Claude, use my Codex, use the third-party validator, and locally, when I needed to just focus on my content and I don't want to send it out, you can use something like that card with a lower-end model that's just doing tool calling, and it runs fantastic for that purpose. And that's where your light LLM steps in as a proxy. So you could set all my applications to use one API key to go to that one proxy. The proxy makes the decision as to which model that it should be retrieving that with. And that will save you a ton of tokens and a lot of cost overall. So the last piece that we had on the AI security side is all these AI enabled attack vectors. And that same power cuts both ways, right? So what we're using for defense and analytics, we can also use on the offensive side. So whether that's deep fakes, voice cloning with synthetic audio for any kind of fraud, social engineering. I don't know if you guys have heard this kind of stuff, but it's super simple to do. I've done it many, many times. and basically I can go and do some deep research on you on your Facebook account, right? And you've got pictures of you with your parents, for example. And then I find your parents, and all I need is about a 10-second voice sample of your parent, and then I can then regenerate their audio, calling you, asking for help. It sounds like them. If you can get a little bit of context of how they talk or how they operate, even better. And next thing you know, you're going to help your parent, right? They call you, they have issues, it sounds like them, and you're giving away information or things that you shouldn't be, or authorizing things that you shouldn't be. So that voice cloning thing can get really scary really fast. Automated phishing, even at a scale, that's probably the hardest one, where you can consume all the data about a person and find out what they click on, what they do in a daily life, and then use AI to help really drill down some personalized phishing and get you to do some stuff. My wife just asked me this morning, she's like, hey, I got another one of these from Apple that was talking about I needed to change my password and this and that. I'm like, you know better than that. She goes, no, this one was actually showing from Apple. And then we go and look at it, and it was extremely detailed on what she was getting through. It knew exactly when she had logged in last or this and that. So it had harvested some data somewhere, but it was a very close and very good phishing attempt. Yeah, you got it. The virtual kidnapping side, absolutely. There again, a little bit of voice cloning, and you can do a whole lot of bad things really, really fast there. And if you get their voice tone and their correction, like I played with this with my wife when she was doing that podcast stuff, you can really get it to sound like them. Now, at first, it doesn't. I mean, it sounds like them, but something's off. You just have to tweak the temperatures a little bit and a couple of the other little settings in there. The inflection in their voice, do they talk fast or slow? You can really change that and dial in on that person. The last one there is AI accelerated tooling. So doing all of your reconnaissance in a much faster way. How many of you said that you are familiar with pen testing or teach those kind of concepts in the classroom? Okay, good. So with that, you guys typically teach like Nmap, right? For doing recon, along with some other tools in that realm, using Kali Linux or Parrot OS, something like that?
Yes.
Okay. Have any of you ever seen Core Impact, that tool?
Back in the day.
Yeah,
Kind of
right?
expensive.
Super scary to watch back in the day, wasn't it?
Yeah.
So those of you that aren't familiar with Core Impact, it was a really cool cybersecurity tool that I think they showed me that in back 2008. We did some pretty cool demos with that. Nowadays, it's astronomically expensive to use unless you run a business for it. But what was interesting in that is you basically dropped you in a network and did all the Nmap scans, all the IP scans that you would be normally used to. And then it would have access to the CVEs. It would start determining which systems were vulnerable based off the scans, and then actually go ahead and execute those attacks. Next thing you know, what you're really watching is just a bunch of terminal prompts pop up on the screen. And you had already owned and had access to all those different systems in a very short amount of time. That was pretty cool. It was a very expensive way to do it. In that day, we had Metasploit, and then you had things like Metasploit DB that allowed you to do a very brute force way of doing that. A lot of times it wasn't the cleanest way to do it, but it did work, and it allowed you to drop in a system and just start banging around until you got access to it. Now, obviously, if you're doing pen tests, that isn't a clean pen test, but if you're trying to test IDS, IPS type solutions, it was fantastic because does it recognize it from the inside of somebody attacking versus the outside? Now that kind of goes to the nth degree with AI because it can consume that information, pivot, and start off the next attack, or generally do very slow reconnaissance, which is always the hard part when you're doing pen testing, but it needs to be done. And so you can rate limit that out. You can give it the scenario of what you're trying to do. And there's some really cool models out there that are very specific to pen testing. So you have things like Kali GPT, I believe was one that was out there. And that one really just kind of walked you through and answered questions. I've never seen one use the good tools yet. Is anybody familiar with one that uses the tools specifically, or is it more of a guide walking you through the test there?
I actually haven't seen any useful trained, cyber trained small language models.
Yeah, that's kind of where I was stuck. So like this one, I was really excited about when it first came out, and really all it is kind of an assistant or a co-assistant that's just trying to walk you through what you should look at or what you should do. It's really just a knowledge base of all the tools on Kali, and kind of pointing you to the right tool.
We're starting to do some experimentation with function Gemma, being able to use that as the tool caller for a more general purpose SLM.
How is that working?
Just started with it. It's really, really good with function calling. So like getting the tool, but it doesn't discern. So it needs something else to do it for it, like a different Gemma model, one that's not fine tuned for just function calling.
Gotcha.
But as part of like a multi-agent chain, that's where it's pretty good, because a smarter model, like say, the Gemma, I think it's like an 8 billion parameter model, can help plan and then dispatch function Gemma, or Llama, one of the smaller Llama models to do the work. You get your own refusals a little bit.
Interesting. Like I said, I laugh because every time I do this search, I've never heard of any of these. And there was a bunch of other ones not too long ago that people were, quote, using all the time. It's interesting how quickly these change out. I'll have to look into that function Gemma there.
It's basically just a tool caller. So like if you have a bunch of Python tools or shell scripts or things you want to execute, then it can do that. So you don't actually have to call them. It can also call them semi-deterministically. So if you wanted it to chain different function calls together, it could do that. It's just not a general purpose model. So it's not instruction tuned.
Gotcha. That makes sense. So that's why I was curious if anybody had actually gone through here and seen any of these different pen testing. Like I said, they pop up all the time right now. I'd be curious. That's one of the things I'm gonna have my pen test class do this fall, is realistically just download these VMs or download these models on the systems that we do have, test them in the environments that we have, and which ones actually function like they should. That'll be my graduate pen testing class. We'll spend a lot of time on that this fall. And then obviously once we do get something like this, my goal is to build that back into like that SOC environment so that we can do automated tests and pen test against the students, that kind of thing. I've done a little bit of one-offs in terms of doing the capture the flag events, but then having an AI that is really just like you have tool calling, and those tool calls are to go out and shut off or turn off different things on VMs during the CTF. If they did protect themselves. So whether they're doing the blue team side or the red team side. Mostly they are supposed to be doing the blue team and we're attacking from the red team side. But I wouldn't call it anything like this where it's actually doing a bunch of testing and that kind of stuff overall. All right. Well, I'm going to check back in on our boy here because I know it's looking for something. So let's see what it can do here. So the last status I had, let's see where we're at here. And let's pull it up on this side. So we did get our models out. I think the last one there was getting Kali out and pushed out. It looks like Waza is fully pushed out. So we should be able to hit those consoles for that. I believe the last thing it was really doing was trying to build out the rest of the OpenSense box, the firewall. And that was to make sure that it's doing its SSH and DNS type calls going out there. Right now, it's trying to get Kali to install some tools yet, and it doesn't have internet. So it'll patch in our firewall and make sure we have outbound access. There we go. So here's a good status report of where we're at in the hole. We currently have all the VMs deployed. The templates are built out, Active Directory, everything's been configured. We did build a jump box. Let's see if I can get to that again here. By the way, you can see how this context really starts filling up over time. Yes, go ahead and patch those firewalls. We also have Waza rebuilt and hardened, and that was because when I went to deploy some of this, Waza, when it ran out of storage space, it was just crashing. So I made sure that you guys will have some hardening there. If it's going to fail, it's going to give you guys error messages, that kind of thing. A lot of that was just resizing that Ubuntu partition. Waza is up and going. Looks like we're actually bringing ingest from 3 active agents. So our analyst, our Ubuntu, and our DC. We are in the process of setting it up for 50 Waza agents as a whole. 3 of those have actually been enrolled in the system. And the last little piece here was me trying to integrate those AI tools as well as the documentation system. So it went through my old code and trying to revamp it to fit this environment. Looks like we're getting pretty close to having everything built out. And then, like I said, at the end here, you guys will be able to download these templates, the VMs. If you want to build, or like the Windows ones, if you got to build them from scratch, it'll walk you through going to grab the ISOs, putting them in the right folder, and then go ahead and launching the install scripts. How many of you are interested in using this fall, even if it's testing or in a classroom environment? Great. Good deal. I would definitely funnel the questions and stuff to Chi, and we'll see how we can get that out. And then, like I said, I hope on committing all these different changes and additions and stuff, so it makes it a little easier for you to go deploy it. And the way I have that set up there again is you check out the repo. You can either follow her instructions to build out the virtual machines, or you can do it in terms of infrastructure as a code where you give it the parameters you want and it'll go ahead and deploy them. Or the best route, if you can do it, is deploy it with Claude Code. And the reason with that is it will analyze your systems for you, tell you what you should probably tweak to make this work on your environment, and then walk you through step by step on the deploying side. So the Tofu way, it will walk you through step by step, but if there's any major tweaks or anything like that you got to do, you would have to go edit the file. If you were to do that with Claude Code, even a $20 account or free account, it would walk you through those steps and then go ahead and update those files automatically. I hear you, Daryl. So we got about 15 minutes till the 3 o'clock hour, usually for our next break here. Does anybody have any feedback or anything that they would like to see out of the rest of today? Most of it was I wanted to build this interface out. So for those of you that wanted to test it out this fall, use the AI tools in that environment, that you not only had the AI labs and the stuff that I had here, but you actually have a way to put this in a real lab environment in your classroom. So does anybody have any feedback on what the material or anything else they'd like to see so I can plan for that during the break?
Are you talking about tomorrow, Jason? What are you? Is that what you're?
Just in general and today, basically. If there's anything else you guys want to see for the rest of the day that I need to go off and patch during break or pull more information on, that kind of thing. Like I said, otherwise we'll just be working on that environment and kind of a workshop space. It'll be open forum, so to speak. So if you got other topics like we did here today, I appreciate you guys having those conversations today. Again, that's what I really like about workshops, is trying to listen to those problems, because you're probably not the only one with those problems, especially when it comes to budget and hardware constraints, etc.
Honestly, I would love just the I go home and I nerd out on the videos a little bit and go through some of the stuff you showed in slow motion and get
Sure.
a little bit down. So I just want to make sure you're posting that video.
Oh yeah, no, they're definitely out there. You should have. Let's make sure that the YouTube land actually pushed yesterday's. It did. Great. So I'll definitely be posting out the ones here from today and the first part of tomorrow as well. So if you have limited resources and you want to kind of try that out this fall, it's going to be hard to deploy that entire SOC type setup just because of the sheer number of VMs in there. If I am possible, we're going to get that Discord channel set up. As a matter of fact, it's set up. I just need to get it posted out there on the resources so you guys can get it. If I have my lab set up and it's up and going, then I can even give you remote access into that so that you would have the ability to see what it would look like deployed. I'm happy to share that on that Discord channel this fall if everybody gets joined up in there. If I can get the resources, and I may have those resources here, at least for the time I still work here, I could even host some of those for you in the spring. If somebody doesn't have the hardware, but they want their students to have that ability to have access to that, I may be able to pull that off and get some people access. Whether it's sandbox to that, or even at that point, I'll probably have it wired into a NetLab environment, and so I can get you NetLab access to our system to do that. I'll start the recording back up here. I kind of pause it in when we're silent, but I definitely try to bring it back in. No problem. Like I said, for the rest of here today, we were just kind of working on this environment and kind of having an open forum chat. People wanted to share some stuff, kind of preparing us out for tomorrow. And like I said, we'll focus on a recap in the morning, go through the exam, and then basically share all resources between everybody. That'll sum up the week. Unless you guys want another half again as much content, and I can figure that out overnight. No problem. All right, so it looks like it was finally able to get in and start configuring the rest of the OpenSense stuff. What it was having troubles with was getting the SSL cert over to it so that we could just SSH in and take care of everything from there. So in this environment, Chi, what is the main VM that the students will interact with? Analyst one, okay. And you said that one should have a console at this point? So I'm wondering, looks like I set it up with maybe using Ubuntu server as the base. We'll see if it actually built a desktop out here, because it should have had one. It says it did.
Yeah, I've already done a couple practice labs on that one, so it should definitely be fully up and ready to go.
Okay. It may be rerouted on this side, so let's just do a reboot there. There we go. And if we go back out to your deal, I'm sure you give us all the username and passwords. VMs. Do you list out the username and passwords in here somewhere, or are they all the same?
Which passwords?
For like analyst one.
No, I didn't put any passwords in. I kind of just wrote them down
Nope.
in one of my notebooks.
Let's
Which
see.
password do you need to be able to get into the actual VM?
It'd be whatever my setup is the password. So I'm wondering if it just set up a default across these. So I can chase that out of here. I just wanted to kind of show how these guys would interact, or how the student would interact on analyst one. So and then your intention is you would just clone off analyst one however many times for however many students. Is that right?
Yeah, I plan to have about at least 4 clones of it.
Okay. Resource wise, this system seems to be handling that many VMs pretty easily without any real hiccups. So most of you that are using this in the classroom, what kind of server hardware specs do you have available in the classroom? Whether it's an old desktop or maybe an old server or something like that, what kind of specs do you guys have? Obviously, I know yours, Chi, because it's documented. So Dell 840s, okay. HP GM10s, yep, those work pretty well. So you should have more than enough horsepower, Chris, to run these, that's for sure. There you go. Yeah, we used to have a local ISP here that has donated old servers to us, which is essentially e-waste for them at that point, but they work fantastic for in-classroom stuff, especially when Proxmox came out. We could really breathe some life into them, maybe with some extra hard drives or a little extra RAM from all the different systems. Okay, yeah, here's the little CyberLab engine thing that I was working on a while back. Obviously, this was an older version with it being broke, but see if the logins still work. Most of this is going to be a little defunct because I'm just running it as a container here and it doesn't have access to all the back end, but let's see if we can get it. So the idea in this one was it was just a cyber range, and that they would have the ability to do multiple different activities, kind of launching into this environment. And so getting started, they could come in here and play. That gamification that you were talking about is really this up here at the top. So they would end up with a score that would build over time, how many days they participated, how many badges they had won over time. In this one, I had loaded up about 6 training labs, but there was a bunch of different courses, anything from Linux foundations, network fundamentals, being able to do detection analysis with traffic dump, that kind of stuff. So I built out handful of courses that you could do on the cyber range. And the idea behind those is as they completed them, say on the Linux basics here, let's see if it would actually give us some scores there. That's what I was hoping it would show. They would end up with like that same thing we were talking about, was like a leaderboard and some points. And so the more they go and the more of these they complete, they end up with a whole slew of badges as they go through there. And you can see all the different badges, whether they were participating every day of the week, you get the winner streak, got 100% on any one of the exams, that kind of stuff. So this was that version of gamification I was trying to build into the new dashboard just to keep them interested and wanting to come back. It's amazing, just a little bit of gamification in there, and the students want to actually do it. They forget that they're doing homework, and really they're just trying to be the first one in the class or something in between there. So this kind of look and feel is what I'm going to try to add in on the little sock project that she built out, that it would just overlay everything that she has in there and add points based off the scenarios that she had. And then as we add more scenarios in there, if they're doing different things and trying to, figure out logs in certain scenarios, it would give them points back, kind of create a leaderboard over time. This AI tutor was kind of that early stage and when I played with that. So this one, it's obviously going to show offline, but this mapped to a local model that ran right there in a Docker container using Ollama, and it was given certain system parameters that it would just assist with the different courses. So every course would give us almost like a RAG where it would reload the particular course's help tips and tools and point them out to the different tools that they could interact with. So, and again, it popped up in a little box. So no matter what lab they were working on, for example, if we started on one of these training labs, of course, this part's going to fail, so it may not actually show up here. But what the way that worked was, instead of having all the VMs out there, like in a NetLab environment, everything would be set to the templates. And then at runtime, when a student wanted to actually do a lab, it would go ahead, provision brand new VMs, be set up for them. And it usually only took about 2-3 minutes. It was actually really, really fast because everything's just using hot clones. But once it spun off their system, again, I knew this would fail because it has no backend at this point. It would spin them up. They would actually get the console access right there in what you saw. So you can see this VM console. This proxies directly to the Proxmox system, and they would still have the ability to, when it's up, they can power off, recycle, all the fun things that you would have on like a NetLab side. And then once they completed all the individual tasks, which it would give them that content over here on the left, the instructions that they need to do to go play with it, it's grading them as they do it to make sure they actually ran those commands. So they would end up with their individual points, and then at the end they can mark it done. It would check over the whole system and make that go through. And then once it was all done, they could go back to the labs and mark off the different tasks there. So again, it's going to be looking a little broken here because it has no back end to actually touch. I just wanted to spin it up so you guys could see. So on this term of gamification and such, is this kind of thing that those of you that were looking to add gamification, is this kind of what you were looking at?
Yeah, I'm definitely going to watch back and see how you. This is cool. Yes.
So my intention is that this underlying engine would just be available, and then you can apply this to different projects that you're using in the classroom. So you would just have this as a base hood, and then you could add whatever else to it. originally this cyber lab was written just that way so that you could author the course content in any way you wanted, whether it was questions, labs, layouts, whatever's in there. It would just run within this cyber lab environment. That way I'm not the one that has to generate the content all the time. But same way, like here, this one was going to take you deep into a security onion, and this was just kind of a straw lab type situation where it would run you through the different things, and it would take quite a bit. So it would take you through Kibana and being able to triage alerts and correlate logs, that kind of thing. Obviously, this was before like what we were talking about with AI, so it'd be interesting to mix those pieces in there. There we go. Let's see if I can get this login here. I just missed those credentials wherever they went. There we go. It looks like lab admin. Ah, and it looks like my config file didn't set one. So that's part of that spec that it pulled from yours. Like it said, you didn't have username and passwords in there. So it's going to set some out. And there again, there'll be a config file. So if you want to adjust it for your environment, you just change the config file and it'll go through and reset all the VMs to have the right username and passwords. Great. Looks like it was able to configure the OpenSense from the back end. So we now have internet access out to Kali, which means it can go pull all of its packages that it needed. Apologize why this is using. I need to use the restroom. I'll be right back. Okay. We'll see if we can get this password amended out there. There again, kind of with this environment, did anybody have any thoughts or anything that we should be adding or testing in this? I know you guys haven't really got a hands-on yet, but hopefully you've got a chance to look over her project and the different pieces that are listed out there. So on these future expansion ideas, you got any feedback or anything on that, Chi, what you were looking for? I do know that we have this implemented. That will definitely be there from the get-go, as that got implemented on the OpenSense firewall. And I assume this is what you were talking about for attacking and doing scenarios. Does that sound about right? She must have stepped out for a minute. Let's see. I didn't have Jeremy in here today, so I was checking. Oh yeah, there we go. How many of you have actually played with pfSense and OpenSense? Use them in the classroom? pfSense, okay. Combination of both, Chris? Gotcha.
Used to just use primarily pfSense, but they've changed the model. You have to sign up, use an account, and kind of use the online installer and things. They put some speed bumps and hurdles in the process that makes OpenSense more appealing now. And then looking at, what you were saying as far as automated deployment and stuff like that, I understand how that could definitely be a little bit difficult considering it's the system architecture for it.
Yeah. Yeah, and that was big reason I jumped ship on pfSense. It was always the go-to for almost everything, and a lot of customers that we set up were all pfSense customers, but OpenSense has definitely kind of made its name and added the same features. I think the only thing that's holding it back is some of the extra packages that pfSense has, but OpenSense is gathering them quickly.
Yeah, there's a lot under the hood that I don't necessarily routinely use in pfSense anyhow. So it is nice to have features right there. But if what you need is sort of down and dirty basic firewalling routing, then OpenSense has been just fine for me.
Yeah, I've literally used it for lots of production environments. There's no question about it. I use it for actually all of our NetLab system that runs off a larger OpenSense installation. All my infrastructure runs off that, unless I've got a Ubiquiti in front of it now in some cases.
Yeah, we've been using it for our lab router firewall for several years and never had any issues.
No, it just runs. That's kind of the beauty of the the different operating systems, it just works. Like I said, out in industry, it's real common now. I know a lot of our small, medium businesses around here capitalize and use on it unless they have the budget to go with, for example, a Palo Alto, or sometimes they'll go off with random firewall vendors.
Sticking it onto specific hardware, like matched for that purpose, or just like NUX or virtual.
Usually we have the specific hardware vendor under the hood that'll do that. The Netgate appliances, if they're doing the pfSense side, OPNsense, since they recently launched their hardware. As a matter of fact, I think we finally got some on order to do some testing. That was actually what I was going to replace my one here at Fort Hays with, was one of their bigger hardware-based models. This one here actually, because it would allow me to get my full 25 gig throughput depending on which uplink I had coming in.
Yeah, it makes a lot of sense to go with a little bit more robust chassis on something like that if you've got the throughput, if you got the availability in the pipe.
Yeah, that was the big kicker on this. Is granted we could build little boxes, or sometimes I'll just run them on like one of those Lenovo servers, for example, and be able to pass it through because at least I have the hardware there. But these are fairly reasonably cost. It's not like they're completely above and beyond for what you would get, especially with that kind of throughput. So, I was trying to see what their current prices are, because usually they weren't that bad.
Yeah, are these what does it cost?
So I was trying to find here, because usually they list that, and it wasn't all that unreasonable. There we go. Which one was that? This one had the 25. Yeah, they jumped up a little bit in cost, about $8,300 for that particular model. But again, that is the big dog that'll do up to 50 gig worth of throughput, 60 gig. I think
pretty robust.
Yeah, I mean that's a pretty beefy system. Even the 10 gig one was the one I think we were originally going out. Yeah, it's about half that cost. And now if you get into the small ones, like the ones you could use in the classroom, they get real reasonable. These little desktop ones, you're in that 700-800-ish type range, so it's not unheard of.
Even for our little lab, I've always just virtualized it, but I could see, putting it on some small hardware like that definitely has some advantages, not having another dependency, another link in the dependency chain.
Yeah, and honestly, we put them on what is the name of those? It'll come to me here in a second. Protectly's. So we'll put these guys. This is actually what we do most of the physical open ones now. These little Protectly boxes work fantastic for doing these, especially in the classroom. They're great. And we've done anywhere from the 4 ports to the 6 ports. And now you're in that real reasonable range. They do no problem doing the throughput that I need to do in small, medium business type solutions, especially if you're not trying to get above, these will do 10 gig SFPs. So you drop a SFP to RJ45 and you'd still have 10 gig ports there. Now it won't push that much, but you can have that connectivity. I like to use these as my backup jump boxes right now. So what we'll do is we'll deploy OPNsense on it, and they're my backdoor. If my Palo Altos go down or something like that, I have these connected to another connection. Sometimes that could be anything from 5G to just another port uplink from that ISP, something like that. And then it has a real robust VPN to come in, lands me on that network as if I'm a device, which is a little complicated with some of the open firewall or the open firewall, open VPN. You can do it, but they don't really support it like they used to. Works really well though. Like I said, with these little single thread performance, we can shove a lot of traffic through these little $200, $300 guys and have no problem with it on there. I haven't actually got a chance to play with the SFP models. Most of the ones I have are these three here, the little 2.5 gig ones. Back when we only had gig service, to the house here, these little guys worked perfect for that. Little simple Intel processors, $200. You throw this up and you throw up a couple APs behind it, and away you go. Unfortunately, like I said, now I've fallen into the Ubiquiti game, so tend to have those routers and switches and that whole ecosystem. Yeah, you got it, Chris. Like I said, I ran full UniFi stuff behind this, and then I finally just broke down and put some beefy Dream machines and some other stuff in there, mostly because I was selling to customers, so I like to run it at the house to demo things. They're one of the few vendors that I don't mind having locked in. That's yeah, they just get you so much detailed information. So when I go to troubleshoot for a customer, I can pull in, exactly what's on one port, what's it is, all the client data. It's one nice interface. I can do it from my phone. So if a client calls me, it doesn't matter where I'm at, I can pull up their system and do some real fast troubleshooting that you can't get out of some of these other systems. Besides Chris, does anybody run Ubiquiti, whether it's in the classroom or at home or? Like I said, I had used their wireless stuff way back in the day for being able to do some point-to-point stuff, especially over long distances. I had used their really old WIF stuff that not the UniFi side, but the WIF side. And now with the UniFi side, you can do a lot. You can get all this great data. My students, which I have as employees, they'll go out and do wireless studies for me. So like I said, we go out to a new customer's house that wants some access points. They complain about things dropping. They'll come in and we'll use NetSpot is a really good tool for that. And as what is it, NetSpot? I believe it's NetSpot. Yeah, there we go. Yep, that one there. So this is a really good Wi-Fi tool if you guys are teaching wireless and wanting to do wireless audits or that kind of stuff. You can get their free version. You can do it on your phone or your tablet. We do it straight on the laptop. You don't need a fancy Wi-Fi connector. That was one thing I was trying to get them to understand is, yes, we could put a very beefy Wi-Fi adapter on the back of the laptop and do a scan, but that doesn't really get you realistic data because everybody else doesn't, your other clients in the room don't have a big powerful antenna. So it's best to use something that was a normal client that you would normally use. So a straight up laptop works great. And we can use it as a channel analyzer. They basically we try to get blueprints of the room if we can possibly do that. If not, there's some great solutions for doing that kind of thing, building out the blueprints. So we get something like this, and then they do exactly what you see on this screen. So they'll walk around to a couple different points in there, take readings as they go through, and it gives us this nice readout of the signal. And that way we can do some better planning with what Ubiquiti would have. So Ubiquiti has some great tools there as well. You dump that same floor plan back into their system, and then you can extract that data out and kind of do a coverage map and place different APs in different locations to see where you'd have issues. Especially in the commercial side, the Ubiquiti side works great for that because I can put in stone and glass and concrete. And get a much more realistic wireless coverage map, and then to compare that back to NetSpot. For, like I said, on the education side, you can get this really cheap. So it's like $59 for the home stuff, but if you do it on the education side, I'm trying to remember how we did that. It was not outrageous at all. I want to say it may have even been this enterprise license, but they did it at an educational price. And we got it fairly cheap. There we go. It was 20% off. And they gave a little bit more on that when we were through there. We would love to use the Echo House. So, and the commercial side, when we're out doing with customers, we'll have access to some Echo House. If you haven't played with those tools, they're fantastic. They don't get much better than that. Trying to remember how that is. So Echo. I'm going to butcher that naming here. Echo House. There we go. And these are like the gold industry standard for doing this, especially if you're dealing with significantly bigger ones. So these guys will have the tools to actually build the maps out, as well as do the wireless studies in these. So these are fantastic tools. They're super expensive. I'm still working on seeing if we can get educational pricing on some of them, whether you're wanting to use the Pro and you can use the wireless in that, or they have their own dedicated hardware where you literally, it's like a backpack. You just wear it, start walking around. It takes all the samples, and then gives you extremely detailed information coming back out. Not one that you just want to go buy unless you guys have budget to spend. Try to remember what the cost was on these. Want to say it was around $2-3 grand a piece, something like that. Yeah, they won't even show it here on the website. It was interesting though, because they do have like their Echo House University, so trying to align some of their training with what we were doing, and that was some of the biggest work that we had in that cyber institute, was just going out and auditing wireless systems, both for security but also weak signals, things like that, where these guys are throwing up boosters left and right and just clobbering themselves and everybody else around them. So. And yes, there's good tools even with Ubiquiti. You can use Wi-Fi Man in order to port that in. Their little planner works extremely well, if I can remember where that is. Design Center, that's what I'm looking for. That one there. So if I take this off, I'll pause my recording here. Any other topics you guys want to try to cover here in the last 15-20 minutes?
Holy cow, I didn't realize even what time it was. Whoa.
Yeah, I know. I'm sorry. I apologize if it seems like I'm trying to have filler here at the end, because I wanted us to be able to work with this, but also have these great open discussions. So. And it sounds like the growing consensus is everybody got saturated with a bunch of data. So now they just need time to digest it.
Yeah, that's definitely, I mean, I'm keeping up as best I can, but yeah, there's a few things I need more practice with. How many of y'all out there, I mean, I know you do, Jason, probably, but have your, I'm assuming home networks where you can play with this. Say I go home and that's where I can play with it, because we currently don't have it set up here. So I can't do anything while I'm watching, but I can go home and do it. So it's been helpful for that.
No such luck.
I can honestly say I don't have as big of a home lab like I used to back in the day. Most of my home lab stuff is now, was being hosted here at Fort Hays. And that was to let some other students do it. We got a lab here, and my wife gently asked me to get rid of a lot of my home lab stuff that was down in the basement. And I agree. It was taking up about 1,000 square foot in the basement. So I brought so much of that to the school and let the students dumpster dive through there and grab all the pieces. And they dug out old wireless projects. We did a really cool wireless project this spring that kind of revamped something I had done back in 2004, where we mapped out every single access point in Hays, Kansas, where the college is here. And at that point, there was like 5,300 and some odd access points. And 5 gigahertz had just kind of really became prominent, but it was Apple only at that point. And so we went back, and I had a student take all my old hardware, and then we revamped it with all brand new hardware, built a pretty cool antenna array, and we strapped it on top of a Fort Hays car. And he spent his spring break re-driving all the streets in Hayes and gathering all the new information. And it was amazing how many access points had come up since then. Because back then, you know, you had the one that the ISP provided you, but he would find that, you know, cars have access points now. Everything has access points. Kids walking around with tablets. So there was just a massive plethora of APs out here. And then we would also go through and double check the security and see how that was. That was the big push, you know, 20 years ago on that project was we couldn't get the ISP to understand that, you know, setting things as WEP and using the cell phone number, or at that point it was the house number, right? Was not a good idea. It didn't take anything to go look up in the white pages when they were still a thing. Go find the house, go find the phone number, and you could jump on their Wi-Fi. It was extremely easy to do, if they even had security coverage whatsoever. And when they did, like I said, it was all WEP, so it took all of about 5 minutes to break into. And by the end of that project, it was great. We finally got the ISP to change their security practices when they did the deployment, especially when we published it to the local paper. And I worked with the ISP at that time, so it was a help force move this along. It was good though. It was actually led to a different job where I went out and trained all the technicians to make sure everybody was consistent, because every town was different. You had, I mean, my goodness, there was 200 some odd technicians out there deploying all these things. So a little bit of tangent from the home stuff, but it's great to see students go take after that. And it was fun to watch them take a lot of that old hardware that we built, because we built custom routers and all sorts of stuff from scratch, and they got to build all new custom stuff all over again. And sadly, Terry, a lot of my experimental place is either done now on those MSA2s, or I do a lot of experimenting stuff out there on DigitalOcean, where I can fire something up, test it, do what I need to do, shut it back down, and it just doesn't cost a lot of money to run out there, and I don't have to worry about some hardware that I left running on that side. If you are looking for hardware, I think we talked about that a little bit last time. It's been a while since I found these. Obviously, the MSO1, MSO2, those are great systems to start out with. I do have these little B-Link boxes. So these were kind of my go-to little mini PCs for a long time. They used to be about half that price. Yeah, no problem, G. Sorry to hear that. But these were great little boxes that I used. You can load them up with Proxmox. Can't throw a ton of VMs on them, but it is a good little box to have at your home lab if you want to run Docker containers for playing or learning different pieces. These are really good little lightweight systems. Throw that in the chat there. Again, when I got these, they were $144. They were really, really cheap for people to use. I've used those. I got a whole stack of them over here. Mealy's are another great one. So these little boxes are even smaller yet. They tend to cost a little more, but they're 100% fanless. So I use these at a lot of customer locations where we need a jump box or something on their network that we can get in and troubleshoot with. We don't have to worry about them overheating, fans clogging up with dust and dirt and all that kind of stuff. So anything in that N95, N100, that's the other thing. They use absolutely no power, this N95. I think the draw on it is like 20 watts or something like that. It's really ridiculously low, but still has enough horsepower to do anything you want it to do.
Yeah, that's the suggestions I want more of. That's great.
Like I said, it was real fun when they were only about $140. I mean, you pop one in here, you use one over here. They weren't going to break the bank by any means. Um, at 288, they start to get a little pricier than they did at that time. That's for sure.
This is what grant money's for.
Oh yeah. And like I said, these work great in the classroom if you just need little jump box, little desktops. They're little 4 cores, 4 threads, still have 8 gig of RAM, so they can run a little bit on them. Drivers are fairly easy. They come with a full Windows 11 license. They used to come with 11 Pro. I think now they come with Home, but you can easily wipe that and throw that over on a Linux box, and you'll get a lot more juice out of it than you would running it on Windows. Anybody else have any kind of hardware like that they use? See if we can set that password on that box finally. There you go, Dara.
That was weird. I dropped out and dropped back in. Okay. Sorry about that. I think
No, you're good.
we popped out, popped back in. I was like, okay, that was weird.
Yeah, the one after the B-Link that I showed you there is the Mealy.
Yeah,
This one here, sorry.
that's the one.
And again, whichever model fits your best. This Quieter 4C is good. These are a little bit beefier than that last one. They do have the N100 models. These, like I said, they're a little more expensive here, but sometimes they go way down. I don't know why they're so expensive right now, probably tariffs and such. Little overkill too, because those have like triple 4K displays you can run off of them. That's really what I started using out those other ones for. The B-Links, is I use them for all my digital signage. So those all talked back to my head end, and it was really easy for me to just have the customer buy a 50-inch, 60-inch, even 70-inch TV down at Walmart for 100, 200 bucks. We'd slap this PC on the back of it, and next thing you know, we had full-blown digital signage. So that worked really, really well. And then because they were so cheap, we used them for jump boxes and anything else to bounce into a customer's network and just pivot through there. The beauty of doing stuff like that is we didn't have to set up, specific VPNs. If they already had VPNs, great, but it kept us completely out of band in that regard. Well, let me see if I can get this console to finally fire. There we go. Hey, we got a password that works. So obviously we go in and clean a little bit of this up. And like I said, the idea here is we would put an icon out here on this desktop that would go ahead and take them straight out to the dashboard. And this dashboard that we would build out would be a place that the student would get a login. You as instructors would be able to log in, assign accounts to students, that kind of thing. But they could then log in and do all their documentation and pieces there. You would also get that cyber engine type look and feel so they could see what labs and things they need to complete. But you would also then be able to launch into your Waza instances and all sorts of pieces there. So Let me see if I can pull out those IP addresses and everything we set up. I know it's in her documentation here, but let's see if I can't rip that out. I think that just comes up in the basic 2155. I don't even know if it's set to the right time zones here. So me locally, like I said, I'm in Kansas. I'm central straight up. About 4:55 here. We're going to go for about 5 more minutes. Like I said, we'll probably leave a little early today where you guys can go off and experiment with some of that kind of stuff. And hopefully after that exam tomorrow, we'll have all this packaged up and you guys will be able to download and install when you're free for class. Good question if it actually set a time zone. Not sure if it ever did. All right, so like I said, we'll throw in some look and feel for those of you that have never seen Waza, for example. Get that set up in those pieces. So this is what a student would go in to get access to the Waza system, which is all the log, the scene kind of thing. And we're going to eventually have the EDR, the outputs, and that kind of stuff. So admin, oh wow, it created a really complicated password. That's all right. Obviously, we wouldn't have them logging in with the admin password, but this is all kind of that initial setup after the fact. So I'm curious if it did finalize everything. No problem, Daryl. We'll see you then. So great. It looks like some of our automation works really well. In this case, it was able to configure Waza for us. Yeah, no problem, Wendy. Not a problem. Like I said, I planned on leaving here all within about 3 minutes so people could catch up on everything in between. This is great. It looks like we actually got our 3 agents deployed. And those 3 agents are our Ubuntu app machine, our analyst machine, and our domain controller. So all those got set up and.
Okay, wait, walk me through. How did you do that again? That's impressive, but how'd you do that again?
Yeah, so the Ansible, because of the way she had it originally set up in her pieces, when I ran the deploy scripts here, it uses Ansible in order to communicate into Waza, and then it go ahead and set up those agents. Now, the students would be responsible for adding additional agents in here. So they would come to their agent management and summary, scroll down here, and then we could deploy a new agent. And whether it was a Windows box or a Linux box, this is usually pretty straightforward. You add an IP address and the agent you want them to be on. If you're adding them to individual groups, which it pre-built out some of these groups for us, and away it goes. And then they would take that software they would need to install on their far side. So you could go grab the package from either this website. There's a couple different ways to do that. If you do it from the Linux side, it'll actually tell you the commands to actually install that once you enter in those IPs. Windows is the same way. If you come over here and do a Windows, let's say we call it test system, and we come down here and give it a, oh, where's the server IP? There we go. Whatever the server IP is. So 10.1.1.2. No, that's not right. 10, 10, 20. And what that'll end up doing is giving you a nice little URL. So I can come out here, copy this command. And then as a student, I would log into that Windows system, open up PowerShell, run this invoke command, which will download the MSI file from Waza. Go ahead and install it and then tell it to report back with this particular agent name that we set up. So setting up agents is really, really easy, really slick in Waza. And then once those agents are back there, they're going to report information on the operating systems. It will scrape all the logs that come in from them. So if we came in and look at the dashboards or the logs coming in, which we don't have a dashboard yet. Back to the home side. We can see the severity levels come in, and this is it pulling from those particular agents like Ubuntu Lab Adder, and we can see that there's some default usernames and passwords and stuff that we need to clean up. Those are all just little minor security stuff. For example, in our SSH config, we're permitting empty passwords. We should go in and fix those kind of things. So it's doing audits on the little PCs and agents that we already have in this network. And this is where you get to learn the ability to stretch in a bunch of filters and logs and that kind of stuff. So what's slick is this works really well, but what we've seen in better deployments is we build a nice little MCP server with Claude. And so instead of us trying to remember the search filters and pulling all that stuff out, we can interact with an AI to get that same information to us and organize it in a way that we can see it. You still need to teach this side of it, but that side is extremely efficient because it'll help you correlate that. And that's what we have on the agenda or plan here tomorrow, is to kind of demo that, hopefully by the time we're done with our exam tomorrow. Like I said, nice little preview into what we're going to see here tomorrow. And then still got a couple last pieces to wrap up here. Get this cleaned up. We'll get it pushed out to the GitHub repo. Going to do a quick shout out here to see what else we have that we wanted to finish up. So it looks like we're almost done with our scenario VM that will allow us to inject traffic and run multiple scenarios. The student platform will be the next one I'll work on here tonight. That'll be the whole little SOC board where they're going to go through and do all their documentation. We'll reuse from the CyberLab engine the way of doing gamification and scoring, and then be able to finish up the last little assistants, including our AI assistant that we're going to have deployed out on this NLP VM. Be able to do our detections and passwords and seed the labs. And so a little bit of work, but not too much left, and we should have a full working environment. Probably where I'll close it off here today. Stop the recording.